Hello, everyone. I'm Ksenia Zamukhovskaya, and I'm glad to welcome you on our third and the final day of the conference. Before we move on to the program, a small announcement. Any participant can organize their own Blitz talk. To apply to do that, please go to the suggested topic for the discussion tab and fill out the form. If the program committee will approve your topic, the topic will appear in the schedule. You will listen to the 12 different topics today. It will be in the Earth room at 5 p.m. Moscow time. So please stay tuned to the schedule. And now I'd like to introduce to you our first speaker, Kohei Kaigai from HitiriDB, who will present a topic, GPU version of Postgres and GIST index. This topic will be in pre-record, so we'll now listen to this talk.
Thank you for participating in my online presentation. My name is Kaigai Kohei of HitiriDB. In this session, I'd like to introduce our recent effort to run PostGIS functionality on ZPU, titled ZPU version of PostGIS and GIST index. First of all, let me introduce myself. I have contributed to PostgreSQL since 2006, about for 15 years. And I started my own project that tried to accelerate PostgreSQL workload using ZPU. It is named PGConf module. And regarding to my company, I established HitiriDB about 3 years before. Our company focused on ZPU accelerated database technologies. Today, we introduce its functionalities. What is a PGConf? It is an extension module of PostgreSQL that try to utilize GPU power, GPU computing power for processing terabyte scale big data. It is implemented as extension modules. So from the standpoint of users, they run SQL query as usual PostgreSQL. Then PGConf add an alternative execution plan using ZPU that allow to run where clause, table joining, and group by on ZPU processors. It dynamically generates ZPU code from SQL and runs just-in-time compiler. It is usually designed for IoT and M2M grade log data processing, and the biggest characteristic of PGConf is I/O acceleration using NVMe SSD and utilization of NVMe SSD and ZPU. And last year, we added new infrastructure to focus on geospatial analytics as an accelerated version of PostGIS. It is today's main topic. Since this is an online conference of PostgreSQL, so some of participants may not good at ZPUs. Recently, ZPU is very frequently used for machine learning and artificial intelligence workload. But it had been used for high-performance computing area over 10 years, and NVIDIA and related company provided very mature infrastructure to use a GPU for general purpose computing, like simulation, computer graphics, supercomputing, and so on. And GPU has more than 1,000 processing core on chip and has a very high bandwidth memory. So it is a very powerful tool to process a large amount of data. We are using these GPU devices for database areas. For geospatial data analytics, we try to solve these kind of workload. It is extraction of mobile devices with location data. See the diagram. When we have a mobile phone or driving a car, here is a position on the on somewhere, and it is it included geolocational position, including latitude and longitude, come from GPS, and it is usually gathered to information system like database, and people also want to pick up devices within a particular area, like prefecture and city or other regions. In these cases, we need to search which devices, which vehicles contained within a particular area. PostGIS is a functionality to use and to solve the workload. Let me introduce GPU version of PostGIS. As you may know, PostGIS is an extension of PostgreSQL to add geometry type and related functions and operators. It was released about 15 years before. Then, developers committee continued to maintain the software. It has more than 400 functions and operators, and R3 index and parallel query executions are supported for more higher performance analytics. It is an example of PostGIS functions and data types. And geometry type can be one of point, that is just point, and line string, and polygon. Geometry type may contain multiple point, line string, and polygons anyway. And when we have multiple geometry types, here is we can define a relationship between two geometry types. For example, ST distance is one of PostGIS functions that calculate distance between two geometries. ST contains is a function to check whether one geometry object is fully contained by others. In this case, this pink geometry looks like contained by the green geometry, but it is not fully contained here. So this function returns false. And st crosses is check whether one geometry fully crosses a particular one other geometry object. In this example, this line crosses this green polygon, and it looks like fully contained since the edge of the line string contained in the green polygon, but it goes outside of the polygon. So this st crosses returns true since it crosses. This evaluation of geospatial relationship is a little bit heavy operations. So PostGIS internally have some ideas for optimization. One idea is bounding box. Since geolocational polygon is a very complicated data structure, like this polygon. So if we can skip evaluation for obviously disjointed objects, when we try to evaluate whether Tokyo within Germany, in this case, Tokyo is outside of the bounding box of Germany. So we don't need to check whether this location is inside of the polygon. It is obviously outside. In case when we try to check whether Stuttgart is inside of the French or not. In this case, bounding box of French contains Stuttgart. So in this case, well, we need to check this point is whether this point is contained in the polygon definition of French. It is a two-phase evaluation. One other optimization idea is R3 built on top of GIST index. It is constructed on top of a bounding box, and I'll introduce R3 index later. So let me skip this slide. So we PGConf built some PostGIS functionality on GPU device code. Why it is capable to accelerate? Since GPU contains many processing cores, more than 1,000 processing cores on a chip, and it has a single instruction multiple thread architecture that allow to run many concurrent threads for many of database loads simultaneously. In case when PostgreSQL's CPU parallel, multiple worker process fetch multiple rows in the same timing. But in case of GPU parallel, it fetches more than thousands of tuples almost simultaneously. Then GPU evaluated thousands of tuples on the same time, then writes out the result set. It is a reason why GPU is capable for SQL accelerations. Look at this example. We try to run a query that contains a PostGIS functionality. It is a simple select from a GIS test table, including where ST contains. That is a PostGIS function. And when we show explain output, PostgreSQL's query optimizer choose a GPU scan custom plan on GIS test table. And look at GPU filter. ST contains GIS test A, GIS test B. That means GPU scan plan choose ST contains can be executed on GPU devices, and it generates GPU kernel code on the fly, and it is already built to the binary mode. It also shows a kernel binary. When we see the kernel source here, it shows this function is built on the fly. It contains a GPU scan queries eval. It is a function called during GPU scan kernel execution in parallel. When this automatically generated function is called with heap tuple fetched by GPU scan kernel code, automatically generated portion extract heap tuple and load a second column and a third column into the local variable, and then it calls preliminary defined ST contains for GPU device code. Since this ST contains logic is very complicated, but this portion is already built on the installation time, so we never built PostGIS functionality on the fly. This slide shows a basic performance of a GPU version of PostGIS functions. It tried to extract the number of points from the randomly generated, and it picks up random points from only contains this region. We run the same query with PGConf and via PostGIS. Here here is a performance difference between two versions. When we run a GPU revision of PostGIS, query result is 44 milliseconds. And in case of CPU, it returned 622 milliseconds. The visualization of the workload is here. We randomly generate a point from 0 to 100, and we try to pick up point area. Right now, GPU version of PostGIS supports quite a limited number of PostGIS functions, including estimate points that makes point object from floating point values, and calculation of the distance, and check whether point is contained in a particular polygon, and so on. But just porting a PostGIS function to GPU doesn't solve all the problems, since when we try to extract points included in a particular area definition, the amount of calculation can easily increase so much, since we usually use 100 to 100,000 area definition, that is polygons, and we usually track 100,000 to 10 million devices. If we try to check the polygon and point combination naively, we have to run a PostGIS function up to trillion times. It is, of course, too large even for GPU devices. So we also implemented GIST index also on GPU. First of all, I'd like to introduce how this index works on PostgreSQL and PostGIS. R3-based GIST index internally contains three structures. Please look at these three. When we look at box R1, it is a bounding box. R1 is here. That fully contains a region of R3, R4, and R5. R3, R4, and R5. So if we try to look at point here, we can see it is obviously outside of R1 and R2. In case when we look at this point on the root node, here is inside of the R1 and R2. So we try to walk into the next depths of R1. In these depths, this point is inside of R4, but also outside of the R3 and R5. So we don't need to look at this leaf and this leaf. So we can only look at leaf node of here. At the leaf node, this point is inside of R12, but outside of R11. So we can pick up we can pick up a polygon presented in R12. That is behavior of GIS index based on R3. And please don't forget to look at second entry on the root node, R2. We come into the next step. When we come into the next steps, this search key is outside of R6 and R7. So obviously, we can stop work down this subtree. So idea is basic. Since GPU has many cores on single chip, so we think thousands of threads, if thousands of GPU threads concurrently search this index, it is much faster. But at the first version, when I implemented this index support at last September, it was, even though it shows a correct result, but GPU revision was very slow. Here is various reasons, but the biggest reason is come from GPU thread scheduling. Since NVIDIA says GPU has 1,000 cores on the chip, but internally it is grouped several streaming merge processors. It is a unit of processing cores, registers, and L1 cache, and some other system resources. And individual streaming merge processor can run up to 1,000 threads on 1,000 threads simultaneously. It looks like a very large-scale hyper-threading in CPU, and individual threads are scheduled per warp. It means 32 threads always share the same instruction pointer. So if workload is very uniform, like matrix operations, GPU can achieve full capability of processing core utilization. But if a particular thread tend to use many processing time, other threads have to wait for completion of longly running thread. This is an internal design of GPU join, original one. When we pick up 500 rows at the same time, and individual thread runs join workload, it calculates hash value, such hash, and evaluation of join condition. That is quite uniform operations. So here is less differences of consumed GPU cycles. But in case of R3 index search, one thread may break R3 index search very soon, but one other thread may come into the leaf node of R3 and come into a join condition evaluations. So here is a large variance of the threads processing time. And for synchronization, these GPU's cores must keep idled. It is a reason why our first implementation of GIST index is not faster than CPUs. After that, we improved this index operation to use temporary buffer, not to synchronize a long-standing thread. Then we run the same workload on the new implementation of GIST index support. When we pick up points from randomly generated 10 million randomly generated point that is inside of Tokyo area, and we picked up a number of points for each sub-region of Tokyo. That is workload of ST contains inside of the GPU processor. After that, GPU returns a very quick response, 100 times faster than CPU version of PostGIS. That is a query execution plan and explain analyze result. When we run PostGIS function in CPU, entire query response time is about 30 seconds, and most of times consumed by nested loop with GIST index on CPU. Of course, it uses a parallel query. And when we turned on GPU version of PostGIS functionality, it uses GPU GIST join plan and load area definition itself and index. Here is an index size. Index into a GPU kernel and runs this index search using this index filter. It says portion executed on GPU finished within 328 milliseconds. That is a very good result. So let me wrap up my talk. GPU version of PostGIS is an enhancement of regular PostGIS to fit GPU parallel executions. And right now, several PostGIS functions and operators are supported. And we also support GIST index for geometry type. It works very efficiently when we pick up zero location point contained in a particular area. In our test benchmark, it is 100 times faster than CPU version. And we expect this workload is used for area marketing, real-time advertisement delivery, push event notification, and so on. These are very computing intensive workload. However, GPU allow to run these heavy operations as you usually run on your workstation or cloud environment. So our PGConf project welcomes your participation, contribution, volunteer, and so on. Please contact us. We publish PGConf at GitHub here, and documentation. Sorry, it is a Japanese version, so please remove JA on tail of URL, and you can contact Twitter or email. Thank you for your interest and participation. That's all for my presentation. Thank you.
Hello, Kai. Thank you
Hello.
for your talk. It was a very detailed and interesting theme. So now we'll have a Q&A session. I just want to remind colleagues that they can address their questions to you in our chat, and I will read them and address them to you. So let's start from the first question from Dorofei from Postgres team. I open to upstream this effort into Postgres.
It is quite interesting, and if it is acceptable, we are open to submit our ZPU enhanced version of PostGIS functions. But on the other hand, our GPU implementation fully depends on PGConf's internal architecture. So as a groundwork for upstreaming PostGIS, we need to define good API to interact between PGConf and PostGIS. It is still in progress.
Okay, thank you. And one more question from Dorofei. What is the best manual to get PGConf and PGConf up and running on my machine?
You can get a PGConf manual from GitHub site. You can see a link to the manual, and unfortunately, documentation related to PostGIS is still under construction. We are actively working to release PGConf version 3.0 that includes a PostGIS support, and we fill up manual stuff as a part of version 3.0 release.
Okay, thank you. And also, Dorofei is wondering how he can take part in PGConf. Where is the community in some chats, mailing lists, or somewhere else?
In the past, I set up a mailing list, but actually it didn't work. So, please send me an email.
Okay. I think that Dorofei can ask you also in the special chat after the Q&A session, and you can talk about it a little more to find the best way to communicate after. Okay, one more question. A common bottleneck when working with PGU is the relatively slow loading data from CPU into the GPU memory. Is the GIST index support effective only if the index is completely in the GPU memory?
Yes, exactly. GIST index have to be smaller than GPU memory. And recent GPU have a relatively large amount of device memory in comparison to the previous devices. And usual workload like up to a million polygon definitions. That is, for these cases, this index is enough small to load GPU memory.
Okay, thank you. Next question is, which GPU would you recommend for PGStorm and why?
We usually use Tesla Plus GPU, V100 and A100. In the past, we also use P40 and P100. Since these grade of GPU have error correction on the device memory. And NVIDIA also officially support general purpose GPU usage by Tesla grade devices.
Okay, thank you. And did you implement other operations than GPU join for GIST?
Right now, GIST index is only supported on GPU join, not scan workload. Since scan workload fully depend on amount of rows to be fetched. So if in case when we have to load entire index first, we don't expect performance advantage by GPU scan. Only this index can work on a GPU join workload.
Okay, thank you. So, colleagues, I would like to remind you that after this Q&A session, you have an opportunity to join a special chat where you can talk, not only chat, but also talk to Kaigai and ask all additional questions about this topic and to discuss how you can continue collaboration and communication. So as I see, yes, I think now we can move to the special chat. Thank you once again, Kaigai, for this interesting theme. And I would like to ask everyone to go to the special chat and to remind that we have Blitz talks. And you can assign for this opportunity. You just need to go to the special and to sign the form, and then at 5 p.m. Moscow time, you can listen to these Blitz talks in Earth Room. You will have 5 minutes, and for the talk, so you need to concentrate on the very specific theme and to tell only the most important information. I see that there are no new questions in the chat, but I'm sure that there are quite a lot of interesting things that you can discuss in the special chat. For now, we'll have a break for 20 minutes, and then we'll see each other in this room for the next talk at 5 minutes past 11. Всем добрый день. Спасибо, что подождали. Прошу прощения за...
Good morning, everyone. Thank you for waiting. Sorry for some technical delays. Our next presentation will be made by Dmitry Dolgov, and the title is How many engineers do we need for the brackets to start working? This presentation has been recorded, and after the presentation, the speaker will join us to answer the question live. Hello, everyone. Today I will speak about JSON-B subscripting in Postgres. I truly hope this is not going to be just a dry presentation or report. It's going to be an interesting story and useful at the same time. My name is Dmitry. I work in Zalando. And in the past few years, I've been trying to contribute to development of Postgres. You've probably heard about my patches related to various JSON-B functions or support of storage in pgdump and PSQL. Before we start, a small note. When I usually present at conferences, I speak really fast. I will try to avoid this today, but if I notice that I speak too fast, I hope that somewhere down below there'll be a button to press it and slow me down. So how much are you tired of this construction? Does it really help you? Indeed, not very much so. This syntax is more or less adequate and ergonomic. But once we talk about the updates, things get really interesting. If you want to update the value of JSON-B by key, you need to do this, which is a good and obvious function, but it makes queries more cumbersome. If you want to do something more complex, update values or on inserted root or something like this, it gets really difficult. So we had this situation in Postgres from the very beginning when functions of update of JSON-B just appeared. How much did you want to use this syntaxes? When you need to use square brackets to indicate what is the value and what key are you going to update or read. Sounds compact. So for select, it may not be as important because syntax has always been ergonomic, but square brackets will be probably closer to the developers like path and style, but there is a difference. You don't need to call any functions. You can say JSON-B, set JSON-B, and nothing else. Everything is good, but if you want to use this syntax, I have big news and good news for you. A patch was committed in Postgres recently which implements this functionality, and I hope that in version 14 you'll be able to use it. And this might be it, the end of the presentation. Why would we discuss anything else? But the thing is, the story of this patch and this functionality is interesting, and I was able to learn a lot with this story. I would like to share this experience with you, and we can also discuss some small things and details explaining why these are those situations were implemented in this patch exactly in this fashion, and how did we come to the design that we have today in Postgres. So let's start from the very beginning, or maybe we'll start from the very end. This is the commit, which actually contains most of the functionality. We see that Alexander committed it on January the 31st, and if you pay attention, this patch contains a lot of people, a lot of contributors, co-authors, reviewers, and who not. This is not typical for a standard patch in Postgres. Why did this happen? Why so many people? Such a modest patch, such a modest thing, not very much related to syntactic values. Why did it require to involve so many people? For example, even if we compare it with JSON subscripting, we can't really say that this function looks as important as JSON pub or anything else. Let's understand why. To give you the full story, I need to provide you the timeline of how it actually happened from the very beginning and how the design of this functionality changed over time. It started very simply. Oleg had a good idea to implement a style subscripting for JSON-B type of data. The idea was really good. I took it up, and after some time, I sent a patch to hackers, which contained the first proof of concept version of this patch. It was quite simple, with very simple design, but everything worked and all use cases were covered. If you look at it with more attention, you'll see that the first version of the patch was sent in August 2015, a lot of time ago. Just for you to understand the depth of this time, for example, over this time we have discovered the boson Higgs. Magnus Carlsen was able to defend his title of the world chess champion. So August the 15th is a long time ago. Why has it taken so much time for us to achieve this? Well, the first version, the feedback on this version was quite good, and the community was interested in this feature, and we understood that there would be a lot of users who would want to make good use of this functionality, but the design had to be changed. As I said, design was kind of proof of concept and very simple. The idea was that we take the current functionality for subscripting for arrays and extend it for it to cover JSON-B type of data. So in the end, this patch could be inserted in many places and to indicate what we need to do for JSON-B or in JSON-B. Such implementation could not be called flexible. This is a rigid logic, and we decide to expand the syntaxes for other types of data. Everything will be really hard. We'll have to do it all from the very start. There were proposals to make this functionality available for any type of customer. For example, for developers of different extensions could implement the syntaxes for their own types of data and provide access to them and make this access much more pleasant. We thought this idea was interesting. We decided to look into it and provided the following version of the patch with very interesting design. The design was very generic, and it added a new field in PG type called tab subscript. This is just a function which returns us the interface on how do we need to interact with this type of data to implement subscripting. If you are interested, you may have a look at it. It is described in subscript except steps, and this is like an index of API, just a set of utilities describing what we actually can do to perform subscripting in this type of data. So what is validation? We have validation, we have reading, we have updating of values, and we have reading of the previous old value, if any. Everything is pretty straightforward. And as a developer, you can rely on this interface and implement a number of routines for a given type of data, and depending on the type of data you have. Obviously, one interface was not enough. We had to use some structure to maintain statuses. In this version of Postgres, or in this version of the patch, the structure was different, but the idea was the same. It was called subscripting web. It was a plan to distribute workloads. So the structure had to be fixed for us to understand where we have everything. It had all the indices, upper indices, lower indices, all the necessary types, everything that is needed for subscripting. So the routines that I described, you simply had to accept this structure. And what do you do with it next? This version of the patch turned out, well, it has been idling for quite a long time. It was in the manifesto for some time, and I think it was one of the oldest out of manifest applications.
And to make it a bit more fun, I even wrote a comment to functionality. It's quite similar. So if you read it, you do not have to read all of that, but in the end of this comment, apart from all the technical information that I described, you can see that if you have read until this point and will submit a meaningful review of this patch series, I'll owe you a beer at the next PGConf.EU conference. Well, actually, indeed, there are several people that have deserved this beer. And unfortunately, the next PGConf.EU 2020 was to be conducted in Berlin, but due to obvious reasons, it hadn't taken place, but we'll see what we have in future. So finally, this patch appeared and we continued our process. We received review and feedback, and one of the most relevant aspects of the review in the very beginning was our performance. It was not obvious for me because it seemed to us that the whole operation will be full-bound maximum, and we just add one call of function, so everything should be quite obvious. So indeed, we provided generic subscription, and the feedback was as follows. This is all generic, and it means that subscription for arrays will follow this functionality as well. How will it influence the performance of the existing functionality for arrays? Fortunately, it was quite easy to create benchmarks for it, so it was easy to reproduce specific situations. We were just to create big inserted array or to get this value from the array by some index, and it did not require any specific knowledge, but we just had to use robust metrics, for example, median, or several launches. And on the whole, fortunately, the overhead was not big for these arrays. It was about 1 or 2%. An interesting story was related to the fact that not all the members of the community received these results. Some of them reported that in their case, accidentally, performance went 15% down, and of course it's not acceptable. And finally, we found out that indeed it's necessary to use the median. That's why this 15% difference was just an error. But one interesting point became the result of this discussion. This is the way we should conduct benchmarks for Postgres that we gathered manually. So the first question that people have you assembled your Postgres with assets or not? What does it mean? It means that every developer gathers Postgres assets just to check whether various conditions specified in specific functions are fulfilled. This is a safety check, just to understand that probably you have forgotten something or some function needs some special entry parameters. So it's obvious that it contributes to overheads. This is like debugs, but not everyone understands what contributes mostly to overhead. Besides, many people use this option, but they forget about it after that. That's why when they do benchmarks, these benchmarks are quite weird. So if you look at Postgres configuration, you will see that assets apart from anything else, also include memory check. This is a very convenient functionality. It allows you to detect various accesses outside the allocated memory. But, of course, this problem can influence your performance. And if you launch Postgres with assets and without assets, after that you profile it, and we will see that the difference is about 20%. So 20% of time was allocated to debug work to check that the memory we use was correctly processed. And about 12% is allocated for Sentinel. It's quite interesting, we need to remember about it. And you also need to remember to switch off the assets backwards after testing. So we realized that everything is quite fun about performance, but you know why I like Postgres? Performance can never be too much. And even if the initial version was quite good from the standpoint of performance, still there is an opportunity to get it better. And Tomlin did it. Actually, he processed this patch, he restructured some challenges related to executed to decrease the number of intermediary calls that we have during subscripting, and thanks to that, the performance was increased. It is very positive. So, it's a good progress, a lot of interesting details, a lot of interesting feedback, and another feedback was as follows. This implementation probably is still not flexible enough. What do I mean? I mean that if we imagine that we want to provide this functionality, this API for custom data type, of course it's difficult for us to imagine that we can cover all the possible use cases. That's why it would be quite good to provide an opportunity to the developers to add some upgrade structure into the intermediary state that after that will be transferred between various stages of subscripting. Unfortunately, in the original planner notes, it was not possible to add it because the planner is free. It can freely allocate these nodes between various workers, but for execution node, that is much simpler. That's why the amendments that we introduced touched upon subscripting restraint structure. It has status of subscripting at the stage of its implementation. And you can note that apart from internal fields that included subscripting ref, here we also have a field that is workspace. It's quite interesting. In this structure, being the developer, you can put everything you need to monitor a status between various calls of the functions and routines that we defined before that in our subscription API. It's very useful, and probably it will be used for, well, actually it is already used for arrays and JSONB, and probably it will be used for JSON-pop as well. So, this topic is a bit distant from my main topic, but it's also quite interesting for me. So, how we receive this feedback in subscripting patch? This philosophy is that if you want to implement a functionality using a call change, and if you are able to use one and the same call change to achieve two goals, it will be better than if you achieve only one goal. Another example that is given in this slide is an old chess wisdom that states that if your opponent has one weakness in their structure, this weakness can be protected. But if your opponent has two weaknesses, it is much easier to win over him. So this is quite a philosophic theme, but it was represented in this patch as well. That is what I mean. In the process of redefining the main subscripting mechanism that was not related to JSONB, it was a basic mechanism, Tom Lane has already implemented a very interesting thing. He conducted refactoring. The refactoring means that we have two different types of arrays, and Thanks to this subscription field, we can distinguish various types of arrays. It is not really important for the user, but it allows us to have refactoring. And actually, I liked this idea a lot because it's clear that every patch by itself is dangerous for code-based stability. And if you cover more various use cases with one and the same patch, it is much better. For example, refactoring or another small functionality, it increases your chances that this patch will be in the core afterwards. Of course, it was not everything. After that, we had a lot of conversations regarding the way this interface should look like. How should JSON be subscripting function? In the very beginning, I was convinced that JSON-B subscripting should function just the way JSON-B set functions. For them to function in the similar manner, in order not to have any differences and have everything in a simultaneous manner. But if you work with JSON-B set quite frequently, probably you know that in its implementation, there are a lot of corner cases. They are not obvious from the standpoint of a developer. And Pavel offered a very interesting idea to make this interface a bit different from JSON-B set and to cover all these weird, unobvious details, make them more flexible and more corresponding to the expectations of the developers. As I already mentioned, at first it was quite stubborn. I was trying to persist, but after that I agreed. We tried it and it was really interesting. So what do I mean? Let's look at various options. What can happen if we want to upgrade one value, one column of JSON-B type? For example, we have a field that initially was null. And if we use JSON-B set without logs node, then if we want to do so, the result will be null. Just because this is a normal function and every entry argument will also have null as a result. An idea for JSON-B subscripting was to change it. And if now JSON-B field was null, after the modification we get a new object. This is an empty object, and we subscribe a value to it, that is 1. So, you will not have an empty column, and after upgrading you will still have your data in this column. That is quite flexible and obvious. Another change that we introduced is as follows. The arrays work a bit differently now. For example, you had JSON-B that was an empty array. And if you want to upgrade its value with JSON-B set function, for example, with the index of 2, your value will have index 0, because JSON-B was implemented in such a manner that, by default, all these empty fields are not represented. So they are not filled in. It's something like an addition to the array, rather than upgrading by this index. Okay, we can get used to it, but sometimes it's not obvious. What have we changed? Now, if you want to upgrade a value by its index, and in this specific JSON-B it will mean that there will be some gaps. These gaps will be filled with zeros. This is JSON-B now. That is very good. It will work for positive indices only. Regarding negative indices, there have been a lot of issues and we didn't manage to find a consistent approach, but it was quite obvious regarding the positive ones. This is the part known as JSON-B filled gaps. So it works not only for empty arrays, actually it works for any upgrade that is outside the borders of an array. Another interesting detail that we have implemented. If you want to upgrade something inside JSON-B, and the current structure of JSON-B field allows you to do so, you will develop a complete structure. The whole way that you specified will be developed from scratch, and the value will be added in the end of this way. The third example in this slide is as follows. You can see that if JSONB field was null initially and we want to subscribe a value by key A, after that by index 0, and after that by another key, in that case we will create an empty pathway with a key. There will be an array here, and the first element will be an object with a key B, and this B key will have value 1. It is very positive because now you do not need to check whether a specific pathway exists in order to add a new value. And there is a trick here. You need to know it. Actually, there have been heated debates about better implementation of it. There were two different opinions. Do we need to upgrade the value in this case or not? And what if we want to assign something following the pathway A, B, and C, and JSONB is an object with key A with the value of 1. In this case, we do not know what to do because we want to subscribe a value, but 1 is not a container type. It is not possible to subscribe anything there. And finally, we decided that it's better to use more stringent approach here. And in this case, such upgrades will return an error. It means that you will see that you are doing something weird. Most likely, well, it's a corner case actually, and most likely such cases will happen by error. And it's obvious that people will expect that this error will be returned following the results of their query. So another question that I frequently hear when people discuss JSONB subscripting, this is intuitive types. And by the types, I understand two sides of this question. On the one hand, there are types that are used by the users of this functionality, and on the other hand, there are the types that are used for developers. These are internal Postgres types. The question is as follows. If we want to upgrade a value by JSONB key, why do we need to have right-hand set value as JSONB? We could use not the first option specified in the documents, but the second one when we state JSONB field, key, and subscribe a value. For example, text or another JSONB, doesn't matter. Well, actually, this question is quite obvious, and in the original version of the patch, everything was like that. And actually, it had a negative feedback. It was quite difficult for us to understand that, but it's quite reasonable. The matter is that, unfortunately, this approach, well, it can be implemented, but unfortunately, in that case, there are a lot of problems inside the system of types used in Postgres. So, here you can see a quote that I received as a feedback from hackers. And actually, it shows that in some old versions, well, probably there are some people that use them, there were old versions of Postgres, and they had this internal problem of unclear subscribing of anything to the text. This problem was solved, and if we want to use something similar to JSONB, actually it will mean that we want to convert any data type into JSONB, and this is a similar problem. Of course, we do not need to repeat this mistake twice. It's better to walk around this problem and use, just like in JSONB set, it's better to use JSONB as an entry argument. And we will preserve the stability of this code base. So, that is not the end. Just as we reached success, there was another idea proposed by Alexander. Actually, people have been discussing this idea for a long time then. It was as follows. Ideally, it would be good to have an opportunity to extend subscription data for JSON-B subscriptions so that in future it will be able to understand other data types, not only the text, not only the pathway represented in a number of subscripts, text, numeric, something like that, but for example JSON path. And that will be even more flexible, even more pleasant for us. And in future, as I understand, it is planned to be implemented. It is not implemented yet, but there are mechanisms for it. And moreover, it's interesting that in this case, this offer actually resulted in a discussion about types, about the way they should be implemented. So in the current implementation, what do we have? We have an opportunity to take the value by key.
We can also use values by index. In this case, we need to take the values from inside. How can we easily use JSON path? As I said, it caused an interesting discussion. Here we need to be very cautious with types of data. In Postgres, there is a similar example where we use this, where the reload function uses different types of this values. And this is an exception. The exception is that we should provide types obviously, in the obvious fashion, and we need to verify whether we can really use these types. If we can use this type in the form of two types, we will be able to track the error, but it should not be put through the Postgres and through the full system of types. At large, for the end users, it doesn't really matter. This mechanism is hidden inside and very well implemented. What you can notice that in the original versions, in the old versions of the patch, you may see something similar. When you say, I want to withdraw values from JSON-B array and transmit some floor value by index. In the current version, it will not work, but I think this is one of the corner cases that could be easily avoided in specific applications. Another interesting detail of this patch is that at some point we received a very interesting proposal from Nikita Glukhov, a very interesting patch. This patch partially introduced what we discussed before, adding zeros to JSON-B intervals, and also add the capability of processing indices, floor index, for example, in a more appropriate standard way. JSON path does not describe any subscripting, but if we draw a parallel between portions of the subscripting and indices of JSON path, you may find the similarities. This meant that float indexes could work for subscripting, and on the other hand, Nikita proposed some optimizations which helped withdrawing value from arrays slightly faster, which is positive, but unfortunately we received negative feedback and we had no time to develop this idea further. In the current implementation, we only left inserting zeros in the JSON-B empty spaces. The rest was left behind. So this is the end of the circle. We returned to the original patch which Alexander committed, implementation of subscripting in JSON-B. Is this the end or not just yet? Not just yet, actually. This is a very long story, as I mentioned. The next morning it had been committed. Some machines in build farms started showing strange symptoms and returning various errors when they performed tests. One of the examples you can see on the slide, very strange message saying that that the system encountered an erroneous instruction. This is a strange situation. It took a while to understand this. Well, I wasn't alone who was dealing with this issue, and we quickly discovered the problem because the community had experience, and the community was saying that there was access to the uneven memory in some of the architectures, on some of the machines which operated on an architecture which did not allow such uneven memory, unleveled memory. Luckily, it was easy to fix it. We only had to resort access to memory. But there was another question: how to avoid such situations in the future, because such things would be good to track at the time of development, and not every development has an opportunity to launch a patch of Postgres on an interesting architecture. And how can we do this to make it really interesting, and how to make it better for developers? Well, we quickly found a solution. Some days after, Alexander offered to go deeper, and he found out, he saw that most of the compilators make it possible to perform tests with respect to leveling of data or alignment without recovery. So those arguments help us gather this progress and track all these accesses to uneven memory, unleveled memory, or unaligned memory, which is very, very good. So we were able to find a way to do this. The only problem was that some functionality in Postgres was linked to the fact that this unaligned memory access would happen at some point. So Alexander expanded the story. He added a new macro to identify those exclusions in the code and allow such access. Although it is clear that those portions of the code had to be implemented on certain architectures. So this is almost the end. This has been a very long story and very interesting one, and with a lot of lessons learned. So what have we learned from this story? Let me share some key takeaways. At large, we have been discussing on how to better approach the patch for Postgres, which suddenly turned out to be too big and too invasive for the community. How to ensure progress for this patch, and how to deliver such a patch to the community. So, the first rule, just for you to understand why it happens and why you receive this or that feedback from the community. Rule number 1 at JSON-B is that any patch, big or small, or any invasive patch for sure, have inherent risks for the whole project. This threat, this risk may be of different size and different severity, but it will certainly be a maintenance burden for developers. So if you suggest a very big patch, you will receive a lot of pushback with respect to this patch. You should understand this because it helps explain why do we doubt whether we should commit a patch, but the implementation is very heavy. In Postgres, we see situations when there are a lot of good ideas, but they remain at the development phase for a long time, at the design phase for a long time, because the community tries to avoid and minimize the risks. Rule number 2, get feedback early from the community. This is not easily or immediately obvious sometimes you don't have a chance to get feedback. But if you develop something and you have the first like proof of concept version, it makes sense to post it to hackers just to get some feedback. Because when you develop something really big for 2 years, for instance, and suddenly upload a lot of code and say, I've spent 2 years on it, people say, all right, but this will probably not work. You've spent 2 years on something that is not clear. So try to get back quick on a regular basis and as early as possible. Sometimes there might be issues with feedback, but in most times you can receive an adequate response from the community. The next rule is split into small chunks, and people sometimes forget about this, about doing this. Sometimes you have to split it into very small and funny chunks, but working on big things, you have to start small and walk step by step. And you may be surprised to see how much progress you can achieve when you make small steps forward with some small patches that add small functionality, which is very well tested, with low risks, and it is easy to add it to the Postgres database. Another rule that really helps, and this can make your life easy. You, as a developer responsible for a given patch, you should, from time to time, write summaries of what happened with a patch between given versions. Ideally, you should describe changes in the design. Well, of course, you don't need to summarize all the small details, but just make a summary for a newcomer to understand what you have done with the patch, just to explain the status of the patch. Sometimes a summary can help address questions. Sometimes you are in a situation when questions have not been addressed and people have forgotten about them because those questions were asked 2 months ago. This doesn't mean that questions can be ignored or neglected. You should still try to answer them, and commit first manager will just say thank you, because in many cases a person who comes without context to the thread, it's a manager. They simply see the status, they understand everything is in progress, and they can make the right decision on what to do with a given patch. Another thing that is not quite obvious: be ready to provide reasonable performance tests and even make those scripts part of your patch set. It's important to assign benchmarks. Even when you are confident things will be good and things will work well, it is better to add various scripts that could reproduce tests for your patch and demonstrate corner cases. Why is this important? This will help you easily answer questions about how things are going with the performance of your patch. This is important because sometimes those questions arise out of the blue. It would be good to answer those questions really quickly, because benchmarking is time-consuming. So really good benchmarking, trustworthy benchmarking, is time-consuming. Maybe I will make a presentation about it. You can search at Hackers and find examples on how to do benchmarking, micro or macro benchmarking. And the second important thing is that those benchmarks, you say that this specific patch has this performance and it has these pros and cons. It's a documentation for the runtime of your patch. So you explain when your patch will work well and when your patch will not work well. You can provide some corner cases or use cases explaining why the patch may work slower. One more takeaway is that sometimes small things matter and they affect your patch. For instance, if you have a big patch that covers a lot of small details, it sometimes helps make this patch address some internal issues. In spite of all the efforts taken by the community in Postgres, there might be some internal issues in the code, some pain points that would be good to address. And you're probably in a position to address those issues. Why not do it? It's a good time to do this. Takeaway number 3 sounds a bit abstract. Be open-minded about design suggestions. I'm not talking about the design here. By design, I don't mean types. I'm not talking about such situations. What I'm trying to say is that let's change the interface that the user will see. Even if you have a clear understanding that it should not be this way, sometimes it might be useful to experiment, and you may see that things are different from what you thought at the very start. And finally, last but not least, this is often indicated as you work with the community. So if you offer the community to review a big patch, even if it is very important and offers very good functionality, reviewing a patch is a lot of work, not for you, but for the developers who will review and commit. So to maintain a balance, you will have to spend an equal amount of time to help the community members, help them with their patch. Otherwise, it will not work. Everybody will offering functionality, and there will be nobody to review this functionality and test this new functionality. So it's kind of social responsibility with respect to the community, and you should remember about this social responsibility, so to speak. That's all I have. It has been a very interesting story, for me at least. I hope you've learned from it as well, and thank you for being with me. Dmitry, good afternoon. Welcome you online. Thank you for your presentation. Thank you for the detailed explanation of the story and all its phases. Colleagues, let me remind you that if you have questions, put them in the chat. I will read them for Dmitry. And if we don't have time for all the questions, you can continue your communication in the spatial chat. Dmitry, could you please comment this texting in the chat? Well, I think you provided comments already in your presentation, but could you please say what have you been texting about in the chat? Well, first of all, let me thank the interpreters. This is a crazy job. I didn't know I would be translated. If I had known this, I would have talked slower. So the way the guys were able to handle the speed of my speech was amazing. So thank you for that. As to the questions were related to suggestions offered by Pavel and Nikita. Filling the gaps when we insert new values in the array, and if we have some spacing. So those spaces will be filled with nulls. What will happen if we insert a value by the index with a crazy value? What will happen? Postgres will create JSON-B and adds it the amount of zeros you requested for. But you can imagine what the subtle trade-offs that we had to discuss. And I think this is one of the ways to satisfy both the developers and the users. It is important for you to know this. I truly hope that you do not insert elements into the array by index 1 to 1 million. So it might be a good solution at some point. A few questions. Would you like to add the syntaxes to bit, rows, ID, HStore, and others? For HStore, I forgot to mention it in the presentation. HStore, subscripting was a side effect, just to expand the surface that we can test, where we can test this functionality. So for HStore, subscripting appeared even before subscripting for JSON-B. For other types of data, we haven't discussed it, but this interface is available for any type of data. So if you have any interesting ideas, you can always put it in the hacker. So any type of data can be implemented in such a way in an extension. For example, thank you. One more question.
JSON arrays are indexed from 0 and from 1. Is there a chance that this contradiction will disappear in the course of time? It's a good question. Indeed, sometimes we do have such questions. Actually, over the time that I've read hackers, only one person complained about it. So probably it's the second person that's complaining, and if there are more complaints, probably it will be synchronized somehow, but until recently, such requests were not in demand. Okay, thanks. Colleagues, I think that we will continue our discussion in special chat. You can join it pressing the button in the bottom of the screen, and in this chat you can ask Dmitry more detailed questions and discuss these contradictions and the ways of solving them. Before you go to special chat, once again, I would like to remind you about Blitz presentations. So any participant of this conference can apply for it. This presentation will last 5 minutes. It means that you can train your skill of choosing the main things and stating the essence of your issue. To get into the schedule, the committee of this conference should approve your presentation, but some time is left till 5 o'clock. So I call on everyone to submit their presentations. It's an interesting experience, and these presentations will take place at 5 o'clock Moscow time in the Earth Hall. So now you can go to special chat, and we will have a break here till 1 p.m. And at 1 p.m. we meet here once again and continue listening to interesting presentations. Dmitry, thank you.
Это самая удивительная способность человека – стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько еще впереди?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально ли это? Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Okay. Hello, everyone. Welcome back to our room. And now I'd like to introduce you Dmitry Fontaine, our next speaker. Hello, Dmitry.
Hi, everybody.
Yeah, Dmitry will do a talk about Postgres architectures in production. And please don't forget to ask your questions in our online chat. I will address them to Dmitry after the talk. So, Dmitry, please.
Thank you very much. So, hi, everybody, and welcome to PGConf.Russia 2021 online. So, we're going to talk about PostgreSQL architectures in production. Before I get started on the main topic, I wanted to also introduce my book, The Art of PostgreSQL, that I wrote and I published on the website. So if you go to theartofpostgresql.com, you will find a book for application developers. So the intention of the book is to teach SQL to people writing applications mostly. So it shows all you can do with SQL in your application. And as part of your conference benefits today, I also did set up a discount code that you can use to get 30% discount with the code PGConf.Russia 21. Okay, so that was about the book. Check it out. And let's get back to the main topic, PostgreSQL architectures in production. So what I like to do with a complex topic like this is zoom in every of the words that I've selected for the title. So what does it mean, this title? First word, of course, is PostgreSQL. PostgreSQL is the world's most advanced open source relational database. This means that in terms of application development, when you write your application, the problem that PostgreSQL is going to solve for you is concurrency, is the ability to do several things in a concurrent manner with different users connected at the same time in parallel, and they're doing different things. And your database layer, PostgreSQL, is going to be able to handle the concurrency for you so that you don't have to think so much about it when you write your application. You can almost write your application as if it was only used by one single user at any time. In production, you will have many users concurrently using PostgreSQL, and that's what PostgreSQL is very good about, concurrency. Then on the title, we mention architectures. In the context of this presentation, we want to talk about production architectures. So we will design production components that are used to deliver your application, the service that you want to deliver to your users, and their dependencies and relationship between each others. So your web frontend, for example, might be connecting to Postgres to retrieve some data and then sending to the presentation layer somewhere else in your production architectures. So that's what we mean here with this choice of word. And then we say that we are going to talk about PostgreSQL architectures in production. In production means that it's live, like this talk today, it's live, it's happening live. Or in the picture I've selected, you can see people managing the broadcasting of a sport event while the sport event is happening. In our job, we are lucky enough that most of the time, we can deliver a service to the users without actually sitting at the console like they do in the picture. The services we deploy are going to work magically all by themselves, and we are not necessary. We don't need to be there for the services to be available. So the very interesting thing about this talk is going to be about availability. In terms of PostgreSQL, if you think about availability, we need to think about both the availability of the data and also the availability of the service. Most other production components are going to allow you to only focus on the availability of the service. And that this makes things much easier. In the case of PostgreSQL, we speak of high availability when you both have access to the service and also the data set, of course. This means that if there is a failure happening, like in the slide with the, you can see something is striking one of the servers. The ideal situation that you want is that you can still use the other two servers that are pictured in a transparent way, in an automated way, and still deliver, serve the same set of data. So to maintain high availability of PostgreSQL service and data, we will need to be able to implement a failover. This is the operation that you implement when you change your production server from one instance to another one. It could be a VM, it could be an actual verbal machine, it could be a container, it could be something else. But you're going to switch from the current primary one that is failing to another one. So this operation is a failover. And if we want to speak about high availability, we're going to refer to how much time during a month or maybe during a year the service was not available. And from there, compute the percentage of time that it was available. If that percentage crosses a threshold, well, usually for high availability, we speak of the magic 4 nines or maybe 5 nines, which means 99.99% of the time your service is available. With high thresholds like this, like 4 to 5 nines, the ballpark that we have to have in mind is that you have about 5 minutes per year where your service is allowed to not be available. Otherwise, you're not going to be able to say that you have a highly available service. If you have 5 minutes a year to handle catastrophic scenarios, unprevented failures in production, well, then maybe you want to automate the operation of failing over to another node. Because to stay within the 5 minutes, certainly you don't want to discover what's needed the day it happens. And while we do a failover, we want to failover to a new system, but a system that still has the same data set as before. And to implement that with PostgreSQL, we're going to mention concepts such as disaster recovery and streaming replication as a technology to use to enable this setup. So the classic PostgreSQL architecture looks a little like what's on the slide here. The slide is simplifying it to make it obvious what we're talking about. In the slide, you see one primary server and 2 standby servers. We usually call the standby servers hot standby. Hot means that those servers not only are able to serve read-only traffic, so you can direct some of the queries to those servers, read-only ones, but also at the time of a promotion of one standby, which is going to become the primary someday, when that happens, your read-only traffic is not interrupted. So that's why it's a hot standby. So in this picture, we have 2 standby nodes, and we have an archive node, which allows for disaster recovery. In PostgreSQL, as we will see later in this talk, the archive is a concept. It's not an implementation. It's not a specific way to do things. It's a concept that is provided for you with a PostgreSQL implementation. PostgreSQL is compatible with the idea of implementing an archive. So that was the overall presentation of the topic today that we are going to dive in now in 2 parts. The first part is I'm going to see what PostgreSQL includes in core so that you can implement PostgreSQL failover. And then in a later part, I'm going to see how to use a specific implementation that allows you to do automated failover in production. So let's dive into PostgreSQL failover capabilities. What's included in PostgreSQL is the foundation technology that allows to implement failover, and it's called streaming replication. Streaming replication allows you to replay the changes that are happening in production on other servers. Here, for instance, in the drawing, we see servers A, B, and C. Maybe A is currently the primary server. Well, if that's the case, streaming replication allows you to connect servers B and C to server A in a way that they replay whatever changes are happening currently in production on server A. In PostgreSQL, streaming replication may be set up as sync, synchronous, or async, asynchronous. But synchronous doesn't mean exactly the word as the common understanding would have it. We don't have a magic wand to make it so that two events are going to happen at the same time exactly at two different locations. That's physically not possible. We have constraints like speed of light to take into account. So we didn't solve speed of light with Postgres. What we do instead is that we are making the transaction commit on the first server, server A in the example, and then wait until it's been committed and known to be committed on server B or server C. And this waiting policy can be set up in PostgreSQL on a per transaction environment. So that's unique in Postgres. Each and every transaction that is running concurrently in Postgres can be set up to either wait for the transaction to be known to be committed on other servers, or to not wait and be async in that case. So it's not a threshold that you need to set up for your whole production. You can have specific, like in the example in the slide, I've set up a role VIP. And of course, the VIP role, very important person. All they do is very important. So we set synchronous commit to remote apply. We want to make sure that whatever they did is already visible on the other servers because we acknowledge their transaction. So this is going to be way slower, but also way safer. So that's the thing you need to find the right trade-off for your application needs. You can also use alter role or alter database to set this on the connection string level. You can also do it like live in the transaction with the set command. Included in Postgres for handling failovers is also the idea that you can have online streaming changes. And I mean, when you set up for a failover, the first thing you have to have in mind is that the current primary server is going to be like having non-anticipated failures, in which case you're going to be promoting one of the standbys to be a primary. And to take care of that, to be able to add new standbys, we can use PGBus backup, which is provided for by Postgres. When a standby needs to reconnect to what used to be a standby, but is now the new primary, we can use PG rewind to make sure that this happens in production during the failover. We can even fast forward a standby node that is far behind, thanks to cascading replication, which is included in PostgreSQL core. You don't need to set up anything. If you connect a standby to another standby that is more advanced in the replication stream, then they're going to catch up. So that's fast forward. And PostgreSQL also includes online standby promotion. We have several tools to do that, such as PGCTL promote or SQL queries that you can use. Included in Postgres is also the point-in-time recovery basics. Like I mentioned before, I told you that the archiving is provided separately. PostgreSQL includes the notion of an archive, but not an implementation of an archive. When you implement your own archiving, please use one of the tools that are already maintained and developed and offered as open source solutions. It's a little tricky to set up archiving the right way, and it can be dangerous because if you have a problem with archiving, you don't have any other solution, you may lose data. So please use either like PG backrest or PGBarman or Wally or Woolgy or some of those projects that are provided for as open source by the community. Included in Postgres is also an important part of the picture, which is client-side HA. When a failover is happening, the first thing that you will notice is that your application, your client, is going to be disconnected. It's going to lose the connection to the primary because the primary is not there anymore. That's why you're going to failover, right? So the thing that the application needs to do transparently, automatically, is to reconnect when the connection is lost. There is no other way around. If you want to be able to handle a failover automatically in production, your application code needs to know how to reconnect when the connection has been lost because, I don't know, something happened to the primary. PostgreSQL provides multi-host connection strings, and there is an example in the slide, in the bottom of the slide, where you can see several hosts are used in the same connection string. So each time the client connects, it's going to discover the current node in the list that has the attribute target session attributes is read-write. This node is allowing writes, not just reads. And that's your current primary. This may change over time, and you can reuse the same connection string again. So that's included in Postgres. Now, some of the things that you might need for implementing automated failover are not included in Postgres. Like I said before, archiving in Postgres is a concept, not an implementation. So please use one of the open source implementations that are already available, like ones I've mentioned previously. With archiving, you want to set up basically two things that are very important. The first one is base backups, and the second one is wall archiving. So that's your focus when you're doing archiving. Another thing that is not included by default in Postgres is the idea that the roles, primary and secondary, standby, the roles are dynamic. Your primary is going to be a secondary someday, and your secondary is only there because you want to be able to promote it and make it a primary when the primary fails. So the roles are dynamic. PostgreSQL doesn't include online membership changes that way. Some advanced protocol nowadays, consensus and gossip protocols, such as Paxos and Raft, they implement online membership changes. PostgreSQL does not. So that's an area we need to focus on when implementing failover. What's not included in Postgres also is configuration management. Say that you do some changes on PostgreSQL.conf and reload in production on the primary, and then a failover happens. PostgreSQL is not handling the synchronization of your PostgreSQL.conf file contents with the standby servers. You need to do that yourself. So most people, they would use something like Chef or Puppet or automated deployment solution around containers and things like that. So usually that part is already automated. What I want to stress out in this slide is that PostgreSQL itself is not going to do that for you. You need to have another solution that is going to implement synchronization of changes to PostgreSQL.conf and PGHBA.conf, etc., among your fleet of servers that are providing the same service. Otherwise, you might fail over and find the old setup that is known to not work properly, and that's the reason why you changed it. For extensions, it's a little more complex. If you do create extension, the SQL part, the catalog part of the extension is going to be part of the wall stream and replayed on the standbys. But most of the extensions are installed both at the catalog and SQL level in Postgres and also at the file system level with a shared object library. If you install PostGIS, for example, you need postgis.so on Unix to be available somewhere. And PostgreSQL does not handle the operating system side of things for you. So when you create extension PostGIS, you need to make sure that the .so, the shared object library on the file system, has been deployed to all of the servers. PostgreSQL is not going to do that for you. What's also not included in Postgres is the ability to orchestrate minor and major upgrades in a fleet of servers set up in a high availability fashion. So you need to schedule properly the upgrades of the binary packages and the restarts of the server when doing a minor upgrade. And this also is a little more complex with major upgrades. PostgreSQL does provide facilities for major upgrades. The main ones are PG upgrade, which is an on-disk upgrade, and logical replication. You still have to do a lot of work to make it happen in production yourself. It's a toolkit. So with that, that's the end of this second part of this talk, where we dived into what PostgreSQL implements that allows you to then, in your turn, implement failover with Postgres and reach a system with high availability characteristics. Now I want to dive into what if you want to automate failover. As we have seen in the previous section, you have all the main elements, tools that you need to automate failover with Postgres. But PostgreSQL doesn't implement everything for you. I'm going to show one specific project in that area. The name of the project is PGAuto-Failover, and the reason why I'm now presenting this project is because I'm working on it. So I'm the main developer for PGAuto-Failover, and I want to share with you what you can do with PGAuto-Failover. PGAuto-Failover is open source using the PostgreSQL license, so you're free to use it in the exact same ways as you would pick Postgres. With PGAuto-Failover, that's the default first setup that you can do. What we can see on the drawing is an application, a primary server, a secondary server, and another piece of software named the monitor. The monitor is acting both like an orchestrator of online membership changes and also as a witness for network splits and other advanced problematic situations you might encounter. In this drawing, what we can see now is that we have a single standby server. If you have a single standby with Postgres, you cannot implement HA. For HA, you need at least 2 standby nodes because you want high availability of both the data and the service. So the way this works with Postgres is with 2 standbys. Still, in some cases, what you want to implement is going to be automated failover, and maybe your project doesn't require full HA. So that's why we have support for this architecture in PGAuto-Failover. It's for people who want to implement automated failover, but don't have a need or a budget for implementing actual high availability. The way to implement this architecture with PostgreSQL is through running those 3 commands on 3 different nodes. Your nodes, again, are going to be maybe barebone hardware setups, machines, or maybe virtual machines, VMs, or maybe containers. It's all fine. You can use what you have chosen to use. And in each component, either a container or maybe a VM or maybe actual hardware, you can run this command on 3 different nodes, and you will have created a monitor. And the first create Postgres command is going to create a primary because there is no other node. And the second time you do the exact same command, you can see it's twice the same. It's on purpose. The second time it's going to talk to the monitor again and realize that this time there is already a primary server. So the second one is going to be a secondary, and that's automated. And in PGAuto-Failover, we often say secondary rather than standby. We consider that a secondary is a standby that is ready to be used as a new primary. So it's a standby for failover. Now, if you want to implement HA with PGConf failover, of course, it's also supported entirely. And the way to do it is, like we see in the drawing now, you will have a primary and 2 secondary nodes this time. We can see some of the also properties of the system with a replication quorum and candidate priority. And we'll get back to that in a moment. The way to implement this architecture, if you come from the previous one, if you already have a primary and a secondary, you just run a new node with exactly the same command as before, and this time it's going to connect again to the monitor and realize there is already a primary and a secondary, and this node is going to be another secondary. Some people want to have 3 standby nodes, and so your production architecture may look like this when you do that. And you might see on the top of the drawing, number sync standby equals 2. In that case, it means that any transaction that is committed on the primary, before it's going to be reported to the application, you want to have at least 2 extra copies of this transaction on 2 standby nodes, 2 secondary nodes. For this to happen in PGConf failover, we require that you have at least an extra standby nodes. This means that you can lose any secondary node and still be able to deliver the number sync standby promise to your application code. The fact that you have 2 extra copies at any time. So that's why in some cases it's interesting to have 3 standby nodes. And how to make it happen, again, for the implementation, it's the same command as I've seen before, and this time it's going to be a 3rd standby node on top of the existing setup. What's more interesting, though, for some cases, is that in the drawing now you can see that node C is a special secondary node. It's not like the others. It's in gray, and that's because the replication quorum now is false. It means that this node is not participating into the replication quorum. It's an async node, asynchronous. So we're never going to wait for it when we commit a transaction on the primary. As a result, as you can see, the number sync standby is now 1. It was 2 before. It's down to 1 because one of the nodes here is not participating into the quorum. And node B and D are still set up as before. Also, we can see that node C has candidate priority set to 0. It means that PGConf failover will never consider this node as a candidate for being a primary, even when the primary fails. That's very useful if, for example, you deploy node C on a separate region or availability zone or data center, depending on what you are working with. When doing that, you just have to say to PGConf failover, hey, by the way, I don't want this node to be used in the replication quorum, and I never intend for this node to be automatically selected to be the new primary. So the way to implement that is, again, to use the PGConf create Postgres command, the same way as before. This time, though, we are adding 2 new properties, options in the command line that we didn't use before. And those are replication quorum false and candidate priority 0. So that's what you do when you know at time of the creation of the node that those are going to be the replication settings that you want to apply to this node. You may also change your mind at any time, and PGConf failover has full support for changing your mind. And so the 2 commands at the bottom of the screen are used if you change your mind, or if you realize later that this is the node that is going to never be a candidate for failover, and also that is not participating into the quorum. Changing your mind might happen because you are putting in production new hardware that has more capacity than the previous generation, and maybe you still want the previous generation to serve as for a data copy just in case, but you don't want to fail over to it anymore. And so you type those two commands and you won't fail over to this old setup anymore. So to recap, what's included in PGAuto failover is using streaming replication from Postgres, exactly the same thing as we saw before, included in Postgres. We are taking full benefits of that in PGAuto failover, of course. And we are also using replication slots, which are not mandatory when using Postgres. Replication slots allow you to have like a registration of the standbys and to maintain at any point in time, make sure that the primary still knows about the standby and remembers about them where they are currently not connected. So that's the basics of replication slots. So we are using them in PGAuto failover on both the primary and also every of the standby nodes. We maintain slots for every other node in the system. Included in PGAuto failover is also an easy way to set up SSL if you need to. And again, you can change your mind after the first deployment. You can add or remove SSL certificates, and you can go from those SSL to self-signed and things like that. And so the idea behind it is that with PGAuto failover, thanks to using the monitor, you can change your mind and change your replication settings dynamically while you're in production live. The main command around this first idea for PGAuto failover is going to be PGAutoCTL create Postgres. That's the command that will create a primary for you, and then a secondary using streaming replication, PGBAS backup, creating the replication slot, etc. It's all embedded into that very simple command. Included in PGAuto failover also is this idea that roles are dynamic. The server, the current node that is the primary, we know that in case of failure, it's not going to be the primary anymore. One of the secondary nodes is going to be elected as the new primary and promoted to that position. And PGAuto failover has full support for the idea that the role of a node is only a current role, and that will change over time. We ensure retention of role during failover, and also we can use BAS backups if needed during failovers in case it's not possible to use PG rewind anymore, and that's entirely automated. We also automate editing the HBA file if you wish to, and there are some options that you can disable automated HBA editing if you have specific security constraints, like a lot of people do in production. The main commands related to that area in PGAuto failover are shown at the bottom of the slide with the PGAutoCTL show URI, show state, show settings. That's the main commands you're going to use that are related to the idea that roles are dynamic. Included in Postgres also is online membership changes, like we just explained before. And in this slide, we can see some commands to change your formation settings, your replication settings, while your cluster is online and live and in production. So you can set node candidate priority or replication quorum. You can change the formation level number sync standbys to 1 or 2 or something else, like we saw in the drawings before. So that's how you make it happen. If you want to change your mind or adjust the settings to a new setting in production, like if you have a budget for a third standby, maybe you want to adjust some settings, or maybe you just are deploying a disaster recovery region that you didn't have before. We also have in PGAuto failover these enable and disable maintenance commands that allow you to make sure that if you're doing like a kernel security upgrade, for example, on your machine or something of the sort that requires a reboot, well, you want to avoid that the machine you're maintaining is selected as the new primary if the primary fails during maintenance, right? So if you enable maintenance, you guarantee that this node is not going to be selected for promotion if the worst happen on your primary during maintenance. Included in PGConf failover also is network split detection and protection. Network split is the idea that maybe some of the nodes cannot communicate to some of the other nodes. In PGConf failover, each node is going to verify often that they are still connected to everyone else in the cluster in two ways. First, by connecting to the monitor, and second, by looking at pgstat replication, which in PostgreSQL is a view, a system view, we call it, that is going to list every connection that is currently active for the other nodes in the system. So if an entry is missing in PGCstat replication in the system view, we know that the corresponding node is currently not connected. And given those information, PGConf failover can make advanced decision making and orchestrate a failover the proper way when the network is split. And some nodes are on the wrong side of the split, and some nodes are in the winning side of the split. All of this is included in PGConf failover. And part of this implementation is called the active monitoring and role changes in PGConf failover. So we implement both automated and manual failover. We have a demo, for example, a Docker image that you can use. And when you use it, the first thing you do is actually a manual failover. So if you want to try and failover to see what happens, with PGConf failover, that's what you do in the first 5 minutes of trying out the software. So we include manual switchover. And if you look at the commands on the bottom of the slide, the last one, you can see PGConf failover perform promotion. And you give the name of the node that you want to promote. So if you're going to migrate, for example, from one region or one data center to another one, that's how you can make it happen with PGConf failover. You just perform a promotion as usual, but this time the new primary that you selected manually is going to be on a new data center maybe. So all of that is included in PGConf failover. And of course, it's a software project, so it's not finished. And so some of the things that we have in mind are not included in PGConf failover yet. We don't include at the moment support for archiving and disaster recovery. The reason I believe we should do that in PGConf failover is that when a failover happens with the current existing solution I mentioned before, well then you need to redo the setup, because those archiving solutions, they want to talk to the primary usually, or at least they want to know which node is the primary. But that can change over time. So once your first setup is done, how do you maintain that during failovers? So that's why I believe we should fill the gap in PGConf failover in that area. Also, configuration management, like I mentioned before, if you change PostgreSQL.conf, this is not replicated on the other nodes of the cluster. I believe PGConf failover is in a good position to tackle that problem. Extension management, it's a little more complex, but I think we're going to be there someday. And then one of the things we want to do with PGConf failover later also is handling automated orchestration of minor and major PostgreSQL upgrades. So that's not included at the moment, not yet. And with that, it's the conclusion of my presentation about PostgreSQL architectures in production. It's the end of this talk already. And please ask me 2 questions.
Yeah, Dmitris, thank you very much for your talk. It was very interesting to listen to it. We have a couple of questions in our chat. I will address them now to you. And just a small reminder, please, for our listeners, please don't hesitate to write to the questions now, because we have this opportunity. And let's start. I think. Let's start from this. Could you comment, please, on the statement that it looks like you reinvented Patroni?
It looks a little like this, but we have PGConf failover and Patroni have very different architectures. And the reason why we got started with PGConf failover is that with Patroni, you need to handle a consensus, distributed consensus solution, such as etcd or maybe consul, or maybe something else. So if you already run etcd in production and you know how to do that, then maybe Patroni is the best solution for you. But if you don't know how to run etcd in production, how to set it up, or to make it sure that, and understand why you need 3 nodes or maybe 5, but not 6 or 4 and things like that, it's pretty complex to run etcd in production the right way. So our customers, they asked us for a very simple solution, simple and robust. And they didn't want to learn all about consensus, distributed consensus, just to be able to implement failover. So that's how it started, that we now have both Patroni and PGConf failover.
Okay, thank you. Next question is, in the situation when we have A as primary, B as standby, with streaming replication and logic replication between A and C, is it possible to inherit logical replication between B and C after primary fail?
So that's a good question. So it's almost like this drawing I'm sharing now, except that node C in that case would not be a physical standby, it would be a logical standby. But PostgreSQL at the moment is lacking logical replication maintenance, let's say, when a failover happens. So there is no tooling around it at the moment because PostgreSQL itself lacks the ability to do that. So unfortunately, it's not in the court of PGConf failover to solve that. It should be solved with PostgreSQL itself, and at the moment we still don't have a solution for it. I'm sorry.
Okay, got it. And did you, one of the listeners didn't get what is the monitor for PG out failover? Is this a separate machine? What should be installed and configured on this machine?
Yeah, that's a good question. Thank you. So that's the simplest design I'm now sharing. And the monitor is actually a PostgreSQL database itself. That's what makes it very simple to use in production. And yes, it should be a separate node. And here is what you should do to create the monitor and run it. It's this command, pgctl create monitor. This will create a PostgreSQL instance and set it up as a monitor, and allow you to then use it as a connection string in the next commands. Also, while answering this question, it was not part of the question, but my guess is that it's going to be the next one. The monitor, as you can see there, is what we call a SPOF, single point of failure. That's also the main difference with the Patroni design. The Patroni monitor is actually a etcd cluster, so the failure modes are very different. In the case of PGConf failover, if you lose the monitor, there is no replacement, there is no automated way to handle losing that node. What we need to understand is that in PGConf failover design, if the monitor is down, well, PostgreSQL streaming replication doesn't actually need the monitor to run. So your application is still working correctly, and your databases are still working correctly. There is no impact to losing the monitor. For the monitor being unavailable to become a problem to your application, well, you need to also, after the monitor is down and during the period where your monitor is not available, another node should be down too before it becomes a problem, either the primary or maybe the secondary. It's going to be different problems, but the summary of it is you need to have 2 nodes down at the same time before losing the monitor is a problem. So I hope that's clear enough, and I'm happy to dive more into the topic if we have more questions around that area.
Yeah, there are some questions about this topic. Let's continue then. Monitor in PG out failover, is it an application on external machine or a server database on another external PostgreSQL instance?
Yes, the monitor is a separate node, as we said before, and it's going to be a PostgreSQL database server. Yes, it's going to be a very small one. So you don't need to have the same capacity as for the application. The monitor is just a tiny database that is used as two things. The first one, as you can see in the drawing there, the green arrows are named auth checks. So the monitor connects to every node in the system and make sure that every one of the node that is registered is currently running and available. And the other thing that the monitor does is implement our failover logic. And the only machine in the setup that makes decisions is the monitor. So the monitor decides who's going to primary, the secondary, and what's next for any of the nodes when things happen.
Okay, thank you. And the next question is there an ability to add a delayed node?
So that's on the schedule. That's a feature I want to add. At the moment, you can do it manually. So if, let's say you have maybe something like that, there is no way at the moment to ask PGAuto failover to make it so that node C or maybe node D is going to be like 4 hours late, so that you can, if you have like a disaster recovery situation where someone did a truncate or a delete in production and you want to still access the data, that's what you use usually a delayed node for. Well, you can do it manually though. So if we go from this drawing to the next one, here we can see node C has been set up to never be a candidate for failover. Once you have this setup, you can manually edit PostgreSQL.conf and ask node C to be late. And because it's not a candidate for failover, you know that it's never going to be promoted by PGAuto failover. So you can safely change the settings and make it a delayed node if that's what you need now.
Okay, thank you. And the next question, is there any plan to provide REST API or any external API?
So that's a good question again. I think we will move in that direction. We are not implementing that currently. Though you might know that the monitor, being a PostgreSQL server, it offers 2 APIs that you can use. A SQL API with a SQL stored procedures written in C that you can call from an external client. And also we implement a listen notify protocol. So you can implement your own client, connect to the monitor, and you can receive notifications about what's happening in the cluster. And you can also run some queries to get the current state and things like that.
Okay, let's go forward. What about trigger some custom command after failover or switch over for system with external pooler to change its configuration with new master?
Yeah, that's so it's a lot of very good questions. Thanks, everybody. This question is actually connected to the previous one. At the moment, what you can do, so if you have like Odyssey or PG Bouncer or something like that, that you want to change the setup of during or after a failover, you can do that by writing the client I was mentioning before that connects to the monitor and listens to the changes with the listen notify. Our notifications are sending a JSON data. So you can write this little tool in any programming language that you like. And so you receive notifications and you can react to them. And you can also ask to the monitor, hey, who is the current primary? And if you do that in a loop, then you can change your setup when the primary has changed. So that's the current way to do it. And we have a contributor, Yorlios Kokolatos, who is currently working on implementing a direct integrated support for PG Bouncer with PGAuto failover.
Okay, and also it's a question about does your solution could provide synchronic and asynchronous replication?
Yes, again, very good point. I should go back to a slide way earlier in the presentation to help me answer that. So in this slide, you can see that the way to set up sync or async replication either through using the synchronous commit variable setting for Postgres. Well, this setting is never edited by PGAuto failover itself. PGConf failover is going to edit synchronous standby names, which is the configuration of which nodes are participating into the quorum when you say that synchronous commit is on or off or remote apply or something else. So this part of the deal is transactions sync or async. That's up to the application to manage. So you're free to set it up exactly the way you like. That falls into the application responsibility. And PGConf failover is supporting that choice with the synchronous standby names setting. I hope the answer is clear.
You in special chat, but
yes.
For now we have a couple of additional questions.
Mm-hmm.
For example, can one monitor server different sets of PG instance? For example, A primary with B standby and C primary with D standby.
Yes, so that's a good question again. I didn't show that in my slides, but yes, you can have a single monitor instance taking care. So the term we use, the glossary, the vocabulary we use in PGConf failover, in that case, is a formation. And so in this slide, we can see a formation with one primary and one secondary. In this slide, we can see a formation with one primary and two secondaries. And you could have a single monitor taking care at the same time of those two formations. So yes, you can use a single monitor and many different PostgreSQL formations within the monitor.
Mm-hmm. Okay, got it. And one more question. What type of checks are made to consider primary is failed?
Can you, sorry, I'm not sure I got this one right.
What type of the checks are made to consider?
Okay. Yes, sorry, I had some audio problem. Okay, so mainly two checks. The monitor is connecting to the node. That's the green arrows on the schema there. The monitor is connecting, it's opening a PostgreSQL connection to every node once in a while. And if it can't connect to a node, then it's going to decide if a failover is necessary. And also at the same time, each node is running, as we can see here, when you start a node, you start the PGConf process. And this process is the parent process of Postgres. And the PGConf process itself, it's going to connect to the monitor and to the local PostgreSQL instance once in a while to check that everything is in order. And it's going to send to the monitor all the information that the monitor needs to make decisions. Mm-hmm. So we have two kind of connections. One kind is from the monitor to the PostgreSQL nodes, and the other one is from the PostgreSQL nodes to the monitor. And given that, the monitor makes the decision making.
Thank you, Dmitry, once again for this talk and answering such a lot of questions from the audience. Now you will have an opportunity to continue the conversation in the special chat.
Yes.
So before everyone is going there, I would like to remind that we're still gathering the application for the lightning talks that will be today at 5 p.m. Moscow time. Everyone from the audience can apply for these lightning talks. They will have 5 minutes to present the theme, the topic, and to discuss it. But for this, the topic needs to be approved by a committee. So you still have a couple of hours to create or to create some idea and to apply for this opportunity. And now we, in this room, will have a break for an hour, and then we will continue. Thank you, Dmitry.
Thank you.
Это самая удивительная способность человека — стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько еще впереди?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально ли это? Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Добрый день. Меня зовут Михаил Жилин.
Hello, my name is Mikhail Zhilin. I am employed by Postgres Pro company, and for these 2 hours, I will be the host of this room. Now we will listen to Konstantin Yevteev. He will speak about building real-time analytics with PostgreSQL. This presentation was pre-recorded, so you can ask all the questions on the chat. In the end, we will discuss them on Q&A session. And remember to rank presentations below the video frame. So, let's start.
Всем привет. Меня зовут Константин Евтеев.
Hello everyone, my name is Konstantin Yevteev, and today I would like to speak about building real-time analytics with PostgreSQL. PostgreSQL is a universal database, and in my presentation I would like to tell you about the way you can use it to build analytics. So, I would like to say a few words about myself. First of all, today I'm Chief Architect of X5 Food Tech. We prepare services for express delivery of Pyaterichka and Perkrosstok. We also launched an aggregator that delivers orders from Perkrosstok, Carousel, and Pyaterichka. I'm an active participant of PostgreSQL community. I started my work from 7.4 version of PostgreSQL, and actually I had a lot of experience in terms of development. So what is our outline? First of all, I would like to speak about the goals of the analytics. After that, I will speak about the way it's possible to make a quick launch on OLTP database. After that, the implementation of data delivery in DWH, scaling the storage, data quality control, preserving stability in the context of past growth, and I will speak about the organization of teamwork and new technical details and successfully resolved challenges of the last year. So, real-time analytics, why do we need it? First of all, we need to have various reports. Decision-making. When a feature is launched and you need to decide whether it works or not. So you take real-time decisions. Once again, we launch various initiatives and we need to understand how valid they are. It's also possible to conduct monitoring with real-time analytics. And of course, these are various machine learning and models related to data science. Quick start on OLTP. First of all, I'd like to mention that today in my presentation I will speak about the development of analytics together with the project. When the project grows and you have a small team and small budget and you do not have a lot of time and you cannot gather a huge analytical team, you cannot conduct analysis, collect requirements to the analytical system, and after that prepare a solution, a long-lasting solution that will work for several years. Because on the start, you do not have a general picture of the project, do not know whether it will succeed or not, and every time when you launch your project, you need to gather metrics and prepare analytics. This is the scenario we will follow today. So, the picture when you have an opportunity to gather analytical data, analyze all the requirements, drafting architecture, and only after that you move on to code, and actually this is the appropriate way, and we use specialized instruments for it, but today I will speak about a different option. So, first of all, when a product is launched, we have an OLTP database that is a monolith, and in this OLTP database there are services and monitoring. For example, the number of users, the number of orders, all of that is monitored, and then analytics is also set in this database, and everything works quite fine on this stage. After that, the product develops, it grows, the loads grow as well, and our primary cannot cope with that. So what can be done in that case? We can set balancing between primary and standby, and we also have an analytics standby on which we can get heavy queries of monitoring or analytical queries. But there are some...
Once we say that the analytical query comes to replica, there are questions that queries may conflict with replica, and all in all, it may happen so that daily operations or val in case of Postgres, all this may conflict and create blockage. I have covered that in great detail. You can follow the links to see this. The next drawback is that we can only do reading and nothing else. If you have several sets of databases, the primary server will have one standby. So this is not flexible enough. So you have to rely on the original sources. And it is hard to scale such a solution. Let's have a look at a more compromised solution. When we have several servers for various services, primary standby, and some federation storage for analytics, and delivery of data with foreign data wrapper or logical replication. There is another unit, data deep deployer. It should be there, and on the basis of our analytics, we would like to provide results to the database through the service or somehow in another fashion. So all looks good, but there are some subtleties. So what are those subtleties? Foreign data wrappers may have issues. We use LTP base, and when you use foreign data wrappers, we ran into issues. When the scope of data grew really large, it was hard to read all this data, so first read and then do something. And somehow this process stopped. And there are some issues with types. Please follow the links to see what type of issues we had. For logical replication in Postgres, there might be issues with failover of logical replication. Also follow the link to understand more. I hope in the future we'll have a solution which is going to be more robust. But knowing all these obstacles, you can still use this solution. It's not flexible enough, but it is not flexible, as I say, because we have data, but we cannot translate sub-multitudes. So here you can see all the logic with data that happens with data. Let me explain how it is possible to get hold of changes from the data source. There are several options. So we can get it by time, depending on the time. So we can download by batch. And then we achieve some overlap, which is longer than your transaction. It works, but there are some questions about replication, how to track replication. So again, follow the link to see more. And the second option that we used is creation of a persistent queue. The idea is that in transactions, log-free, we put into the AGQ transaction queue, so all events are sorted out and you can seamlessly read data without any blockages. AGQ works in batches. It is quite effective and fast. So you can even unlock tables, and it is a convenient approach. So let us move on. We understood how to retrieve data. Let's understand more. Here you can see a more flexible solution when we have our own CDC. What does that mean? So when we connect and read transaction log, it could be in Postgres. So when we read these data, there is no need to retrieve all data, but maybe some portion, submultitude of data, which gets into this data synchronizer, which works quite well. you can use a binary protocol here. So a similar idea was reviewed here. Please follow the link to see this. But there are some nuances. Well, this needs to be scaled in some fashion. So we're now addressing the scalability issue. So when we go down the level, we see more nuances that need to be sorted out. Development load is on your shoulders. So on the one hand, the solution provides a lot of flexibility. On the other hand, you may incur extra overhead because this solution will require further development. We'll probably put it in the open source at some point of time or use some out-of-the-box solutions. But at the moment, we're not ready yet for that. So we develop our own solution for the time being. Here we have synchronous dependency between our databases and the analytical database. There is synchronous dependency, which is not very good. Let's move on. About out-of-the-box solutions. This one, for example, with the big community. So I took this diagram from the website. So we put data here in Kafka. This is the DBA connector. So all looks good. But in the previous product, when we considered this arrangement, we saw some drawbacks of this arrangement. For example, we could not do slot fallover. Well, hopefully soon it will be addressed successfully. So I hope we'll have the solution shortly. But if you assume those risks, the risks of such disasters, I'd recommend you use an available solution, an out-of-the-box solution. In our project, we used our solution. But actually, we took it from the community. It wasn't purely our own. So here we have a service, and here is the database. So we created a library that helped us transparently in one transaction change data and publish some events. We created our own registry of events. All these events were put to the PGQ query. PGQ. This is quite recent. This was done in 2008. Some people say it's an old solution, but as far as transaction queues are concerned for Postgres, they're very well implemented, and I haven't seen a better solution so far. In spite of the fact that it is an old solution, it works well, so please use it. The second option that we used, from the tables, if we had to load changes in the tables into the analytical storage, we could declaratively say that we download data from the table. And in the trigger, we also created a queue. Here is a component, queue reader. It put data in Kafka. So it was a connector. And also the events could be heard by the servers. There could be synchronous communication between Kafka and the server and the services. This was an obvious log. And on the other hand, it was possible to get data from here or create aggregates in the stream. So this is a viable solution which has been implemented in Avito quite successfully. What else can I say? Storage scalability. How can we scale the storage? At the start, when there is MVP and there is small little data, we we have queries and reviews. Fast development, time to market is short, but when the load is growing, things change. So, but the syntax here, everything is convenient. You can perform experiments quite fast. So, evolution of Windows. So, what happens next? So, the queries work slow, and you need to accelerate. To do this, you can materialize views, so things work quite well. So, queries get faster, but problems are space-bound. So you need more time, you need more space, and you need lag because of reconstruction, and there might be locks. So there are some issues, for sure. In general, we can make a conclusion. If you do things right, things will be all right. So what do I mean by this? You need to select a strategy of incremental update. So these are interim steps, but this solution will not work well. You should understand that you have Windows, storage with various architecture, and raw data is transformed into other incremental forms. And then you build, you create batches very effectively. You can update and upgrade in real time. Also, there is another approach, hyperlog-log. If your real-time story is done in one place, you update counts, there might be some inaccuracy. But then you recalculate all data and you put it in the long-term storage. For this, you can use classic or conventional cron, PG agent of cron. It is built into PG admin very well. There are appropriate interfaces all in one place. You can use all kinds of planners, deploy and versioning of code. At some point, better at the very start, you should do everything through review and through deploy. Do not do it in production, but at the very start. And also to have utilities that take care of this. Also to ensure smooth changes as you move into production. What else is important? Tests. Test quality of data, business logic that you pursue. There are tools for that, and also scale the storage. Most importantly, analyze requirements, select the tools, do design. Vertical scaling is a very dangerous path. So there might be a lot of errors. So you need sharding, partitioning, maybe use some hybrid solutions with special tools, things like that. Data quality control. Data quality is important. If data is not reliable, no one will have trust in them. So you don't want to lose trust. Better to do it through business metrics. You can do a lot of verifications, but there are business metrics. So, and please align against those metrics, business metrics. By using them, you will understand whether things are good or not. Also, you can compare with the previous periods and implement constraints and verification on schedule. But number one is business metrics. Compare against business metrics, evaluate against business metrics. It's a key, it's critical. In our stack, we use Grafana, a visualization tool, and also we use this for alerting. Stability at growth. What do I mean by stability? Stability can be achieved through staging to make production smooth. also, we need a tool to deliver changes into production. It's a great tool. I haven't used it, but feedback is good. It works in production in big companies.
И тут, в общем, достаточно вот картинка как раз оттуда взята из его документа.
Here is a picture. I've taken it from their documentation with a good description of the flow. How should the change flow take place? There are various migrators for that purpose. Yandex migrator, UB-Base migrator. You can write your own, but I wouldn't recommend you do this. And also there are solutions for tests. For example, you can use PGTap. Also, for mock, Avito posted extensions which could help simplify your tests and the way you write tests. What else can I say here? TTM, time to market. When we start implementing all this, it may turn out that we become slower, so we increase time to market. So we should move in small increments and keep track of time to market, not to disrupt the process and not to disappoint the customer. This is a journey that you need to cover. It's not that difficult. Prerequisites for data mesh. When we have you have a functional team of engineers, it may become a bottleneck. When you have different product teams, they come to you with all kinds of requests. Well, first of all, there is a lot of cognitive load on the guys who work with you in your team. Cognitive load, as I said.
По результатам этого могут быть, во-первых, сложно и выстраивать ожидания.
So it might be difficult to build expectations. So there might be issues with timelines and deadlines. There might be discommunication or miscommunication. What to do? Change the paradigm. So imagine you have one big data platform and domains. So there is output data coming from the analytical storage, but we better follow this diagram. When we have product teams knowing their product domains, and the team commits to moving towards creation of a product. So we move towards implementation. So we do not focus on the stream of data, we focus on the domain. We do not get data on the product, we create data as a product. And as a result, we get data mesh. So it should be easy to identify necessary data. Addresses should be unique. Data should be of high quality. If there is no trust in data, no one will use it. There should be clear syntax and some standards for integration of data. They should all be together. Well, data sources should be consolidated so that we can make decisions and build windows. So it requires certain integration. Also, security compliance should be in place, of course. The cross-functional team and centralized structure as a platform. Unless you have a platform, distributed logs, pipelines, storage, all these ingredients will land into functional teams. So first as an issue, support, solution, and the cross-functional team will have a very heavy cognitive load and be very busy with separate tasks. But the team should have a focus on the product. There is an article by Martin Fowler. I recommend you read it. And what he writes about becomes a standard. So, to summarize, let me share with you some some important information. So we keep interacting with Postgres. And also the way we read PostgreSQL configure, the way we perceive it in a new way, how long the standby server should wait before canceling standby queries that conflict. So we begin waiting, we reach a limit, then we kill queries, short and long. But it turned out that it wasn't exactly this way. There was a note in the documentation.
And only after standby has 0 lag time, it will reach master, and after that, this parameter will be off. We had it actually when we started building an analytical solution on Postgres. Now we did not see this load, but we saw this unclear behavior on web. So that was quite an interesting problem. The second story. Before that, I had an experience when we were building our system. This was the whole system of monitoring and plugins, but when a team is small, you need a small solution. And to a large extent, the story of Nikolai Samokhvalov helped us. So actually he developed a solution that helped us speed up the analysis of various solutions. And we realized that PGWatch is a good solution with a lot of advantages. So here you can see its main features. It can support various storages, data warehouses, and dashboards are really great. So we decided to use it. But there are some special aspects. Not everything was suitable for us, and we customized it a bit. And when we started updating, it turned out that this task was quite difficult. We wrote a script that applies all dashboards in an automated way, but if you introduced some changes, well, it was quite difficult to do diffs. There are metrics on the one hand, and on the other hand, there are alerts. And in our case, when we have a centralized collector, even 2 collectors for one database, one of them writes everything in Postgres and the other writes it in proxy. And in its turn, proxy writes to metric warehouse for Grafana, and this is the story to visualize and make alerts. Thus, on the basis of this story, we also started developing our own customizations. And it's difficult to support dashboards customs. Not all features were massively used. So here's the list of the things that we found there and corrected. So we prepared bug reports for that. I mean that we're developing it. And an advantage is that open source is a flexible solution. Everything can be corrected and set for you. There is no dependence on vendor. This is a good instrument. And speaking about custom dashboards, I already said that we accept everything as is in PGWatch, and we have our own dashboards. And at some point, it may happen that metrics fail, but if they do, we can solve this problem. We do not have a lot of custom dashboards. So another task is that at some point, one team member joined us, and he said that it was not really convenient to use this scheduler. And it was convenient to store all tasks together with the code base of data warehouse and the schedule. And it turned out that there were some special aspects there as well. At some point, the code failed. Speaking about RAID controllers, this is an interesting story. Software RAID, well, it's quite obvious, but actually it consumes CPU. So, we need to monitor CPU and load average. Sometimes we do not even reach its usage. So, when your machine is used for CPU, actually there will be no waiting time for this record, but you will not have enough resources for recording. And after that, we substituted it with hardware RAID, and everything was great after it. The processor was different here as well, but I just want to emphasize that it's better to use hardware RAIDs and monitor disk subsystem not only from the side of the disks, but also CPU and load average. Another important aspect, at some point we received an error. No space left on device. And this was a very interesting story, because space was present on this device. So there is an index, VEX4, and it was overloaded because the load was quite specific. A lot of temporal catalogs were created. And queries were directed to standby, not primary. So it was quite interesting for us to understand what happened. At first, we realized that it's possible to follow XFS, and in that case, problem disappeared, and I think that many of us use X4, so you need to remember about it. And instead of conclusion, I can say the following. Of course, there are specialized instruments, but sometimes everything can be done with one tool, and Postgres rules. This is the world's most advanced open-source relational database, and that is great. So we managed to resolve another challenge with PostgreSQL. And at first, we need to conduct some preparation work, and this time will pay off, because if you do not fulfill it well, then the degradation will be exponential. Everything will break at once. So please contribute a lot in the start. Another story. Decreasing dependencies. Dependencies on the teams. So that the team could do everything by itself. That is very important. Otherwise, it's not obvious how to manage the development time. And the process of providing changes to the customer. And a working MVP today is better than a space shuttle tomorrow. We always need to remember about it. It's better to move in small iteration, and open source is great because you can amend everything, you can fix everything and set everything for yourself. But for it, you need a specific resource and expertise. And actually, this expertise gives you an advantage. Because having this experience, you can apply wider decisions. You can select from a wider range of options. That's why you should accumulate expertise in your team. That's it. Thank you. And I apologize for coughing. I have a cold. Thank you for listening to me. And now we have time for your questions. And you can find me on Facebook and ask me questions there. Thank you. Goodbye.
Спасибо огромное, Константин, за столь интересный закат.
Thanks a lot, Konstantin, for your very interesting presentation. We have one organizational question from Ivan Konstantinovich Kuzhnakov. What is the right way for organizing your team if you need to build analytics for all systems at once? Well, this is the concept of data mesh, as I understand, yes. Well, there are two options here. The first point is that you can address some teams and organize work
between these teams. So these will be project work. Or if you need to have a stable supplier of reports or solutions, some aggregator, in that case, you need to have another team that will enter these data domains and stay in touch with these teams, or probably receive information from the documents and build the necessary solution. Thank you. And speaking about code base, should the code base be similar for all product domains? I mean, with its own customization, or they can build their own solutions that can differ? Well, here there are no dependencies. It's like a monolith service. Everyone can select their own approach, processes, and solutions. But, as I mentioned, there are common platform tools. Of course, this is quite costly, and common platform solutions facilitate their life a lot. But just like in the classical approach, that is microservice architecture and organization of cross-functional teams, it's also quite okay if technical leaders of these teams decide so, to introduce your own solutions. But the technical leader should understand that the support of this platform, well, it's a policy. Either platform will take it and support it, or the team will support this instrument itself and it will develop it itself. And so you need to decide here, make a choice. Yes. I have a question about the speed of replication. CDC, logical replication, FDW. Actually, sometimes people complain about these mechanisms, that they are not that fast. You cannot take 1 gigabyte per second from there. Well, wait a bit. We need benchmarks. I cannot agree with it. So probably we will not achieve the similar speed as binary replication has. But you need to understand what speed you need. And secondly, if I said that this solution is based on trigger on replication of transaction queues and batching, it is possible to sacrifice some guarantees of fault tolerance and put some log tables and memory, and this will be transported. It will be quite difficult to restore it in case of failing, but it will work quite fast. Speaking about logical out-of-box replication, in that case, we have transaction wall, and if this is a CDC, a specific solution that decodes these walls, it is possible to do it quite fast. And probably the speed will be even faster than binary replication. So it depends on the receiver. If you broadcast it to Kafka, of course we need benchmarking, but I think that it's possible to send everything much faster. It depends on the speed of consumption. Yes, and actually we do not deconstruct anything. In that case, it will be quite fast. It will be even faster than binary replication. Well, indeed, this is the issue of benchmarks and initial data, terabytes or dozens of terabytes. I have a question about CI/CD. Speaking about lab, is it possible to devise a scheme of A/B deployment so that every new release will not break everything at once? That is a very interesting story. A/B deployment, well, look here, there are several stories here. Speaking about deploying code, actually that is quite simple. You need to have versioning and A/B deployment. Actually, we already spoke about it at the conferences. When the whole code is versioned by the scheme, and in that case it will look quite okay, and you can use the previous code version and the new code version. And speaking about migrations and EB deployment, then this task is a bit more interesting. Nikolai Samokhvalov, actually in this conference, spoke about it as well. So they make these casts on snapshots, and I think that this solution is good for testing. But how can we switch? If we make a snapshot, how can we switch from the old data structure version to the new one? I guess that in that case we will need something more complicated. As I remember, in Oracle there is such a mechanism. There is an opportunity to provide for migration that will be reversibly compatible, so both old and new codes are supported. But this is quite a heavy solution. It's not free, but they prepared instruments for implementation of it. And actually we can create a similar thing in Postgres, but this is all about the support. It means that there will be some migrations set that will support the new and old structure, and there are overheads. Well, actually it can be done. The question is the price of implementation and overheads. And I think that it will be better to conduct tests before production. There is another good option. I've just had this idea. What if we just create some logical copies? We will have several contours that are identical, and we will change the structure and send the new code in one place, and the old code will be in the old place, and this will provide for seamless switch over. But I think that for these solutions the price of support is quite high. This is reversed compatibility. Yes, it will be necessary to double the initial query. One query should go to the old place, and these queries should be executed in the new place as well. I mean, the queries that are generating data. But on the other hand, if we have this versioning, probably it is possible to have two different mechanisms. Well, yes, it can be done. So this is all about supporting and using such systems. Okay, thanks a lot. I think that we can go to special chat if anyone has any questions. We can talk to each other and discuss all of architecture. You're welcome, Konstantin. Thanks a lot. Please remember to rank presentations. And now we'll have a brief break for about 15 minutes, and we will resume our work at 4 o'clock. Thank you. Thank you, Konstantin.
Это самая удивительная способность человека – стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько людей?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально это. Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Hi, everybody. So it's time to move further, and next presentation will be in English, and it will be about trends of PostgreSQL storage. And we welcome Yana Krasteva from Swarm 64. Okay. Yana, you are welcome. Please explain us what is modern storage for Postgres. What is the best?
Yeah, thank you very much. So I'm Yana Krasteva. I work at product marketing at Swarm 64. And today I'll be talking about modern data warehouse with open source PostgreSQL. And Postgres doesn't need further introduction to you. I'm pretty sure you all are using Postgres for OLTP workloads, probably in your main production database and as system of records or system of engagement. It's an extremely versatile, resilient, and well-architected database. Not surprising that some of the most famous data warehouses in the last 20 years have taken the code from Postgres and have turned it into very successful commercial products like Netezza, Amazon Redshift, or Greenplan. Differently, at Swarm 64, we have taken since the beginning the road of being an extension to Postgres. We add functionality to Postgres that allows Postgres to execute OLLP workloads. We have taken this road because we want to develop closer to the community and to add such functionality to Postgres. Being an extension also makes it super easy and comfortable to our clients and users to choose the methods on which they want to deploy our product and the systems they want to integrate it with. With all this, we are delivering to the market a no-login, versatile, and reliable data warehouse built on PostgreSQL. Now, let's look a little bit about what is needed to execute fastly an OLLP query. And what is needed is to guarantee effective data movement throughout your whole query processing and keep parallelism very high. So I want the laser, yeah. So first of all, what you need is a very effective query planning. We know that a non-effective query plan can make your query run extremely slow. You also need a way to very quickly access very large amount of data. You need your query execution to be parallel and remain parallel throughout the execution of the query. Fourth place, you need a ways to access this parallelism from your interfaces to the database. Swarm 64 DA adds functionality to Postgres in all these 4 domains by only using the interfaces and the extension mechanisms provided by Postgres, which means that all the functionality and asset consistency you know from your beloved Postgres remains exactly the same. This added functionality is available to Postgres as execution path Postgres can choose to use when suitable. For example, if you have a lookup query on a small table, then Postgres will choose its own mechanisms to index the query. On the other hand, if your query needs a large table scan and executes a complex join, then Postgres will choose to use the functionality provided by Swarm 64. Now, let's dig a little bit more in detail into this bucket. On the query planning side, we have implemented a couple of query rewriting functionalities for the very common query rewriting patterns, like query decorrelation and transformations of not ins into not exists. We have added to Postgres planner costing improvements, which are focused on OLAP query executions. We have a way to keep statistics up to date automatically, and we know that statistics play a major role in your query speed. On the data access, we have followed the path of the very well-known Microsoft SQL Server, and we are adding to Postgres a highly compressed, fully transactional column store index. With the column store index, you smartly skip irrelevant data, and your I/O can be reduced between 10 and 100 times. On the query execution, we are adding much more parallelism to the query execution. We are able to feed our parallel query processing very effectively and to move this data very fast throughout the processing pipeline. We do this thanks to our shuffle node, which transparently and automatically redistributes the data between the parallel processes so that workers can keep on working independently throughout the query execution. We have a join implementation, which is very effective on joining large tables and is meant to accelerate OLAP workloads. So Postgres will use this join when needed for running fast OLAP queries, and in the other case, Postgres will choose to use its own join implementation. On the access, on the increased access parallelism for your interfaces, Swarm adds an output buffer which allows to overcome some of the known inhibitors of parallelism to Postgres, which is, for example, the cursor that is added by several BI tools. I will now dive deeper into the compressed column store index, but before doing that, let's answer a question that probably is in the heads of some of you. Doesn't Postgres have already a column store? Yeah, there are several initiatives to bring column storage to Postgres, and I will explain how those approaches are different to ours. On the one hand, we have the Z-Store, which is developed under the hood of Greenplum, but Z-Store is not really an index. They introduce a new table format with a columnar storage. They use the pluggable storage interface added in Postgres 12 to do that. And in their case, you will need to choose to keep your tables on the on Postgres storage or to move them to Z-Store, which plays a challenge when running mixed workload queries, as in the worst case, you might see a slowdown in your transactional queries. There is also another solution from Fujitsu, their vertical clustered index, which is somewhat more similar to our approach in the sense that they use the concept of defining an index. But from what we have seen, this vertical cluster index is restricted to the Fujitsu Enterprise Postgres. So it's not really clear whether it will work with native Postgres deployments. And secondly, it targets in-memory workloads. Differently, in Swarm, using the Postgres extensible interfaces, we have built a compressed, fully transactional, and crash-safe compressed column store index that can be added to native Postgres deployments. And we have chosen this index approach because you keep all the Postgres functionality untouched. All your transactional queries will be executed against your native Postgres tables. Backup, replication, will work exactly on the same way you are used to. Secondly, only the data that is indexed by the column store will be duplicated into a highly compressed columnar format. Thirdly, the OLTP performance that runs against your native Postgres table is not affected when running OLAP queries against the column store. By this, we enable Postgres to effectively execute hybrid workloads. Let's now dive a little bit deeper into the column store. So how this works from the high level. On top of a Postgres native row store table, we create, you can think of it as a columnar view, and we translate the columns that are indexed by the column store index into a columnar storage. Whenever new data comes in your database, it will go into your Postgres native tables, and there will be a little bit of data that is not indexed yet. We have mechanisms to automatically update very efficiently our column store index. In our first implementation, we choose to use vacuum to do the index update. However, when you run vacuum, you will be updating all indexes, including the ones you have on top of your Postgres native tables, which has some time penalty. That's why in the following release, we are decoupling the column store index update, so our background process will update only the column store index with the freshly arrived data. Now, how you can use it? Let's see that. So if you have, for example, a Postgres native table with 3 columns, you can very simple, very straightforward, use create index, and on one go create the index on top of all the columns in the table. So it's super simple, no-brainer. By doing this, you are not getting into troubles of over-indexing or reducing your selectivity. So you don't have to spend time on thinking how to match your index to how you are going to later query this table. By defining the index over all the columns, you can afterwards run queries in any column or any combination of the columns without penalty. This is thanks to the lightweight maintenance approach we have followed when designing our column store. Now let's look a little bit deeper into how we use the column store for hybrid workloads. So what our column store allows is to run reporting, dashboards, and analytics from the operational database. It sits next to your transactional tables. It's automatically updated in the background. And all this has main advantages. First of all, you have a single source of truth for both your transactional system and your analytics systems. You don't need to invest in ETL or ELT transformations. Any constraints, enforcements, or consistency is defined in one place and controlled by Postgres. So you will have very much fewer of these very costly mistakes related to consistency. We provide a minimum overhead when updating the column store index, which means that the column store index will be up to date most of the time. Now, how this looks from the application perspective. When you run a query, you will be fetching most of the data from the column store. And to guarantee that the results are correct at any time, we will complement that data with data from the transactional tables. Just to give an example, if data is coming in your database at 3,000 transactions per second, we are able to fetch 90% of the data from the column store at super high speed, and then the remaining 10% of the data from the transactional tables. Meaning that you have a truly edged up solution where you run very fastly your analytic queries on your operational database. Now, two things to have in mind. First of all, the more index columns you are selecting on, the less benefits you have from the selectivity that the column store brings. For example, if you have a table with 4 columns and you have defined a column store index on all 4 of them, and you query on all those 4 columns, is effectively like having a full table scan. You don't gain from selectivity, however, you still gain from the advantage that the column store is highly compressed, so you will have I/O savings. We support 2 different compression standards, LZ4 and Z standard, which are available to the user to select which one is their preference, and also to choose on what is the compression effort. Secondly, the index I have already mentioned needs to be maintained, and it might become slightly out of sync, so that additional data will need to be fetched from your transactional tables. Now let's look how all the functionality I've talked about works together. Now let's see the execution of a complex query. And what I mean by a complex query is scanning and filtering of big tables, then maybe executing a join on those 2 tables. You probably have a distinct or unique constraint, and you will want the result from you want the result from an aggregate to be joined with a second table, and at the top you have a sort, and then you want to see only the top 3 results. Postgres can execute such query quite well in the range of minutes. Differently, Swarm starts with a much higher degree of parallelism. It's able to scale the more cores you add to the system and more cores that are available to run your OLAP queries. The plan stays parallel for much longer thanks to our shuffle node, so that the query can be executed practically end-to-end in parallel. All this resulting in a very fast OLP query execution engine that can deliver results in the range of seconds. All this is in theory, so now let's see how this works in practice. This is a small demo environment we have created. On the left, you can see Swarm 64DA. On the right, Postgres 12. Both databases have exactly the same resources, 16 CPU cores in this case, and 192 gigs of RAM with the same SSD storage. I'm going to run one query from the TPC-H benchmark on 1 terabyte dataset. So let me now start the demo. So I'm picking query 16, and we will see that Swarm starts utilizing all the resources available in the system, while Postgres parallelism is limited to a little bit less than half. Postgres starts with a lot of I/O, while Swarm has less I/O. At some point, the Postgres plan turns into much more serial, while Swarm keeps parallelism high. Swarm will finish this query in around 43 seconds. While now we just move fast forward, and we will see that Postgres takes 80 times more runtime, finishing the query in 800 seconds. Okay, this is one query from the dataset. Now let's look how this plays into all the TPCH queries on the benchmark. There are 22 queries on the TPCH benchmark. Postgres cannot run query 18 and query 21, and timeouts in 5 queries. Swarm with the column store can run these queries individually in less than 80 seconds, providing an overall speed up of 20 times. This server is a large or on-premises server, but we have very good results in also in a much smaller machines. Now let's talk a little bit about deployment. And as I said, thanks to being an extension, we are able to keep up with the newly releases from Postgres. We support Postgres 12 and 13, and also EDB ePass server 12 and 13. We deploy the extension only as Ubuntu, as packages for Ubuntu 18, Debian, or CentOS. You can run it in your data center on premise. We also have ready-to-use accelerated PostgreSQL, where the extension is preloaded, and we call this product PGNitros. You can start a PGNitros instance in a matter of minutes from the Amazon Marketplace. We have a very close and very nice partnership with Nutanix. We are Nutanix ready, and we can run on their cloud, and we integrate very nicely in their one-click data management tools for Postgres in the ERA environment. We work close to the community. We have several contributions, 2 patches related to a foreign data wrapper, PGDAM, have been accepted in Postgres 13, and we have several open patches that hopefully will make it into the following Postgres releases. We have a couple of open source projects. I just want to highlight the last one, which is a performant fork for the Parquet foreign data wrapper from Adjust, and in work in collaboration with several partners from the Postgres SQL ecosystem. Now, how you can try it? It's very simple. You can go to our webpage and sign up for a free developer license. You will get your license via email, and you can start toying and looking around in our extension and see how it works with your workload. The second option you have is to use the 30 days free trial for our PGNitros on the Amazon Marketplace. And if you share your POC project with us, we can work together with you and with Amazon to reduce the instance cost, or even to get it for free. And the last option, you have to try the product, and this is something that is coming soon to our webpage, is a SQL playground. In this playground, you will be able to write your own query against the TPCH dataset and see an A/B comparison between SOM64DA extension and Postgres, and also monitor some of the system statistics. So I'm really looking forward having this live in our webpage in the following weeks. So stay tuned to see this coming. That's all from my side. Thank you very much. Happy to address any question.
Thank you, Yana. So we have a lot of questions. First one from Sergey Petrov. He asking about vector instructions. Are any SIMD instructions used for joins? Did you get the question?
Can you repeat? You break down a little bit. I'm sorry for that.
Yeah, okay, sorry. Yeah, no problem.
The last part, the joins, but not the first part.
Are any Intel vector instructions like AVX used for joins to speed up joins?
We use the AVX instructions. Yes, that's part of our requirements. If you see our hardware requirements, you will see that the CPUs we support will need those instructions. Now, exactly for what they are used in the product, that is a detail, but we definitely use those instructions. I don't know if specifically for the joins or for the joins and other parts of the product.
Okay, next question is from Mikhail Shestuk. He's asking about comparison with ClickHouse. Are you familiar with ClickHouse?
Yeah, ClickHouse is a great tool. We have not had the chance yet to benchmark it against our product. So we cannot provide performance results, but our product targets single node deployments in the range of terabytes, and you can see really great OLP query speedups, and it integrates great with Postgres. So it's very, very simple to use, and with any BI tool you want to use.
Okay, good. At least from functional perspective, embedded index is more preferable than external deployment of ClickHouse, definitely. So next question is about synchronization. Denis Smirnov asking, it's not clear when synchronization perform, during insert statement or during vacuum execution?
So in the current implementation, the synchronization point is during vacuum execution. In the next release, this will be a background process that will require a small percentage of the CPUs in the system to keep the index up to date. So it will be completely separate from vacuum.
Okay, thanks. Next question is about horizontal scalability. Something like, do you support partitioning, sharding, or any other solutions?
Yes, partitioning in the same way like Postgres supports partition. We also support partitions, and we have in the roadmap to have an even better partitioning approach, which was more like a range index. And that is something we had in the early implementations of the product that were based in a foreign data wrapper. We are planning to bring that back so we can have even higher selectivity. But even today, if you want to use partitions, we absolutely support them.
Okay, cool. So next question from me. I see you have performed benchmark on huge machine, something like 32 cores. But what's about support of NUMA machines in terms of shuffle workers in the background?
So what we do for the shuffling, we have our own shuffle node implementations. So we have a way to redistribute the data between workers, so you don't have to go into the non-uniform memory access. You don't have serialization points in your query execution.
No, good.
We support that.
Okay, super. Many thanks for your presentation, and we really appreciate such great advantage of column index in Swarm. And as our time is a bit over, so let's move to special chat. If anyone has questions to Yana, you're welcome. Yana, many thanks.
Thank you.
Thank you. Bye.
Bye.
Добрый день. Следующий наш доклад.
Hello. Our next presentation will be devoted to transferring data in Postgres with cloning and other mechanisms, and the presenter is Alexander Nikitin from Data Egret company. This was a pre-recorded presentation. Please watch it, ask your questions on the chat, and in the end of the presentation, we will be able to ask your questions of Alexander. And please remember to rank presentations. Thank you.
Здравствуйте, меня зовут Александр Никитин, я работаю...
Hello, my name is Alexander Nikitin. I am a system administrator in Data Egret company. Today I would like to speak about unobvious issues when transferring and cloning databases and clusters in PostgreSQL. Why did I decide to speak about it? Well, actually, I frequently face similar questions, and I decided to share with you the questions that I'm frequently asked and answers to these questions. So, what shall we consider? Actions with databases, cloning database in the similar cluster, cloning database on a different machine and the versions will be similar, cloning database on a different machine but versions will be different in both cases. So we will clone both from minor to major version and vice versa. And after that, we will move on to working with clusters. We will speak about cloning cluster on this machine, on a different machine, and the transfer of a base or a cluster on a different machine. All the actions that we fulfill during this presentation are conducted from the standpoint of Postgres user. So I decided to select a database from Postgres professional website, 700 megabytes. So, question number 1, cloning similar database in this cluster. Actually, this is the simplest option that we can have. For this purpose, we can use pgdump. The simplest option is to create a separate file and upload database there and download it afterwards. Or we can do it in a simpler way. We can develop DB2 database. This is the second database, it will be empty. And after that, we can execute this command, pgdump ddb1, and the results of this command will be provided to DB2 database through PSQL. So we will have a copy of DB1 database. It took us 2 minutes 21 seconds. So I'm speaking about my laptop. Let's move on to the next option. Creating database with templates. Why is it more interesting? Because actually it is much faster. But here there is one aspect. If you want to develop a database with template, this database should be closed from connections. And there should be no connection inside it. And only after that we can use it as a temple. So what do we do? Throughout the database, we prohibit connection with our template, with our database. After that, we dump all the connections that we have with this database and execute create database db2 command with template db1. And after that, we return the opportunity to connect this database, and it took us 6.5 seconds. Thus, when cloning database, you can follow two ways, and you can suppose whether I can stop this database and close it from users. If yes, then it's possible to select the second way. If it's not possible, then it's better to select pgdump. And this second variant is good because in this case, files are cloned. So you know that your database takes 700 megabytes. And you can calculate the time that it will cost to stop your database so that no one will be able to join it. In this case, it took me 6.5 seconds. So without stopping my database, I could copy it somewhere. I could count the time for copying, and after that, I will be sure that when I create a database in this manner, it will take me 6.5 seconds. Let's move on to the next variant, the next task. This is a database cloning on a different machine. In this case, the versions are similar. So here there are two options, PGDump all, or logical replication. I will not speak about logical replication because this is a major issue. And I would like to tell you about PGDump and PGDump all. PGDump all -G uploads all global objects into a separate file. And in the separate file, you can see the objects that are related to DB1 database. And you know that the owner is a row, or there is some table space that is used there. And from this file, you take the commands that you need and execute them on the server that you need. And the second command creates dump. So this is the first option for solving this issue, and it took us 2 minutes 21 seconds to execute this command. And in this case, we specified that we need to join it with database following this AP, but sometimes it happens that there is no opportunity to connect two machines. For example, one of them is here and the other one is at remote, in a remote closed counter, and the window opens very seldom. And in this case, we can use uploading into an active format, for example, directory, the format of custom or text format, for example. In this case, we will consider uploading into directory format. So what do we do here? We upload it. It shows us that format directory is -Z3, -J4. This is the number of threads, and we put it into we put the directory, we put here all the set of files that we need. After that, we use our sync, SCP, or all the instruments and clone this dump into a new machine. A database is created, and you use PGRestore to restore the database from the dump. So it takes you 2.5 seconds to create dump, and some time is needed for cloning, and 1 minute 30 seconds were needed for restoring. The second option. This is text dump creation. A text dump is created in a similar manner, but here we can notice two important points. Point 1, -C. It means that the script of data creation has command of database creation and connection to it. After that, we provide the result of PGDump command to gonzip, and we sum it up with an archive file. We also provide it to the new machine, and in the lower line, this is gonzip, where we provide this file, and after that, we provide the unpacked files to PSQL, and we unpack them into a new database. And please note that in the end of the second command, I use connection with Postgres database. And although I connect Postgres, DB1 database will be created because in the top screen I used -C key. And it took us 6.5 seconds plus time for cloning plus 1 minute 20 seconds for restoration. When I was getting ready for this presentation, I wrote a script. It uses a lot of possible options of dump execution. I used play dump, custom dump, directory dump with different settings, and I also used not only the zip standards, I also used fix, and as a result, I received this chart. Apart from time of dump creation and time of dump uploading, here you can also see the volume of the dump that was received. For example, the first big yellow column is PGDump. It is 230 megabytes.
And the time is indicated in milliseconds. You can also see the script by which I created this chart. And in the end of the presentation, I will also show you a new curve, new diagram based on a big database, demo big. It is more than 2 gigabytes. And we will run all scripts through it, the ones that I showed you in the beginning. Each test was performed 5 times. We had 31 times, 151 times. Then the time averaged and put into the same graph. Database copying to another machine. Versions are not the same. So we're going up from version 9.6 to version 13. I've never seen that the older version, 9.6, could not install a more recent version, version 13, for example. But I've heard an opinion. If you by means of this binary Postgres, depending on where you migrate, you can do dump, and this dump will restore. I've never encountered this, that older version could not restore on the new versions. And this is the opinion. So all in all, we spent 6.5 seconds. So the reverse situation. We move from version 13 to version 9.6. So we received a binary dump. We wanted to deploy it on version 9.6. And that means that dump was done in a version which our PGM store does not understand. What can we do with it? So we can do it on the new machine, version 9.6, try to install it, but we may get a mistake because we do not know this parameter. It appeared in version 12. That's why we cannot split our versions into 2 big blocks. 12, 13, 9.6, 10, and 11. If you move from one version up, there should not be a problem. But if you move from 13 to 12, there shouldn't be a problem. If we move from 13 to 10, from 13 to 9.6, this problem will be, what can we do? We can restore by using this command. It shows a path to the directory -f. Minus means that you can move to std out and tb1. And we restored within 1.5 minutes. So we say, please send us a text dump. So you receive a text dump. And I forgot to say that in this case, this error will be there, but if when we install a binary file, so it will be there and it will no longer move anywhere. So let me also explain how can you get the information on dump. If you received a dump in the directory format, you can get into this dump, find talk.dat file and ask for 4 lines from it. So, and then you'll get the information that you are interested in. The version of database management system, and also you can get it in the test file. So I've highlighted this important information in bold. Dumped from database version, So moving on, when we create a cluster copy on the same machine, we can face the following issue. When we use the same posts, so you need to do the following. You need to address the issue with the ports and with the table spaces. You need to make sure there are any table spaces compared to those created by default. In this case, we see that there is table space, and here we need to use -t key, which means that we had one path and we're changing it into another one. So after that, everything should work. So we've copied into 13.1. Max rate is a key that helps you limit the speed of reading, and you don't need to overload the database. And this will be read little by little. For that, it took us 16 seconds. When we copy into 13.1, we need to find a port in which there is connection. We enter the catalog, 13.1 data, and try to find a configuration file containing the appropriate information. We change it for a different value, for example, 5433. After that, we can use the cluster of the second command. So we can do this, but it may happen that you don't want to do it manually, but you want to do it automatically. We need to find the file. There is echoing, unfortunately, that prevents me from translation. Very sorry about that. There is echoing.
Здесь нужно отметить, что версии архитектуры должны совпадать. Если архитектуры не совпадают, то тогда вы можете использовать только почту. Второй тонкий момент, то, что нам с вами нужно. Дело в том, что при переходе, например, от одной версии.
So as we move from one version, from one operating system to another, this library may be different. This may cause some issues to you. That's why you can read about it according to this link, if you follow this link. So please use the command referenced on the slide, and then you can use it on the second machine. Syntax 7, syntax 8, you receive different values. After that, we move it into your cluster. You need to send a query, and with this query you will receive the indices affected by the change of the version of the library. So you'll have to rebuild those indices, and only then you'll be able to let the user in. Before that, don't let the user in. It will be an issue for you. Then we create backup. How do we do this? ghba.conf. So we add a row allowing a new server. A new server is 0.193 and the current is 194. So we say that we allow a connection through the replication protocol and perform this command referenced on the slide. And this is by default. It took us 10.5 seconds. The second option is we create physical replica and promote it to the master. In the same fashion, in PGHBA, we provide the number and create PDG backup. We see the progress. Minus H means that we need to create a replica. And at the time everything is good, when you understand you need to switch, you can do select PG promote or PGCTL promote. This took 7 seconds.
Следующий вопрос.
The next question. Moving the cluster to another machine. So what difficult can be here? What is such an issue here? But this is a very dangerous option. It is dangerous because if you don't delete the data in the initial location, or if you don't prohibit access to these data, you may have a big problem. One users will get to the old database, the others through the same application will come to the new database, and there will be a confusion. So the golden rule is, if you don't want to delete all data, so you decided to keep it, make sure no one has access to those data. So how do we move the database to another cluster? We can use PGBase backup. If you want to make sure this database is in another cluster, then the only way out is dump, PG dump. We wait for all the applications to be suspended. Then we say reject for those connections. Then we will reread the configuration and attach all connections to our database. And one more thing, we will prohibit connection to the database. Why? This is not mandatory. But what if someone doesn't know that you have moved the database? It will enter and do something, some reverse action. And then the application will get to your old database. Then someone will try to get connected. The connection will fail. We just safeguarding our future operations by doing this. This is a guarantee that you'll have some backup option. You are double protected. Another option is transition of the full cluster to the via physical replication. This is what I recommend, because we move the full cluster. We can restart to kill all connects. We verify the synchronization of the replica. If you don't like to create a test table and see whether it appears on the replica or not, we remove it, but you can do it through a system function. Then we stop master, turn it off from autoload, and promote our replica to master. We have a new cluster. Let me also emphasize, as you move or copy, you may have issues with extension. Extension for the full text search, it should coincide with everything, so be careful. I tried to offer you all the possible tips and tell you about all the potential issues. And now I'll be happy to take your questions. After we complete the Q&A session, I will also show you a chart and show you what we get when we work with a big database. So now I'm ready to take your questions.
Mikhail?
Mikhail, do you hear me?
Так, значит, смотрите, я обещал вам показать график.
So I promised to show you a chart. When I tested, this chart was being built. I took a bigger database, 2 gigabytes, demo big database, and I put 135 tests through it. So 31 different tests, 5 times each.
And as a result, I received the following picture. Dump is executed a bit slower than the other dump, but it is deployed a bit faster. So this is what I wanted to show you, and this new chart will be in the presentation that you will be able to download. Thanks a lot for your presentation, Alexander. We had some technical issues with sound, and unfortunately, we couldn't hear the final part of your presentation. But I want to mention that the sound will be normal in the recording. So these recordings will be available in a few weeks. Well, unfortunately, we do not have questions on the chart. That's why I would like to ask one brief question. Do you use logical replication for transferring data between different versions? So now we considered base backup, PG dump, but the use of logical replication. How simple it is. How easy it is to do it, or we don't need to do it at all. Well, it's a possible option. I just haven't had a necessity to use it recently. So I mentioned in my presentation that this is a possible option, but I cannot say that I use it every day. Okay, thank you. And what is a business necessity of transferring data from version 12 to a version that is below? Well, I understand why we need upgrades. So 9.6, for example, is too old for us. Well, you mean transferring to a version, to a previous version? Yes. Why do we need it? Well, probably it happens then you have a testing environment and one cluster is present there. This cluster has an older version than your test environment, but in this test environment you have a lot of tests, and for such purposes we actually had to settle such issues. Well, I don't know actually what was tested there, but we have had such cases. These are interesting cases indeed. Thanks a lot. I think that many of us have some questions of Alexander, so you can go to special chart and there you can detailedly discuss the issues that interest you. Thanks a lot. And I'd like to mention that this presentation is final for today in room number 2, but please stay here because in this room we will also have retransmission of lightning presentations that will be in room 1. So please stay here. Do not leave this room.
Итак, наши блиц-доклады. Дорогие друзья, у нас сейчас сессия блиц-докладов.
Dear friends, now we will have lightning presentations session. There will be 4 of them. I'd like to remind you that a lightning talk is a 5-minute talk prepared by our participants right now. Well, unfortunately, we don't have many of them. Nikolai Samakvalov will not be able to participate because something has changed, so it will be quite okay for us to allocate time by 8 minutes for each presentation. So I think that will be quite enough. And if someone thinks that 8 minutes is too much, that's okay. We can speed up, and I will try to speak within 5 minutes. So, my lightning talk will be the first one. Ivan Panchenko. I would like to speak about my experience of developing transforms. So, what is a transformer? You know, in Postgres, there is this notion of transform. What is it? We know that in Postgres, there are procedural languages, not only PLP, PGConf, there are a lot of them. And the problem is that there are its own data types in language interpreter. Postgres has its own data types, and they are not always adequately transferred. For example, Perl. This is a procedural language. Here you can see a simple function on Perl. It takes parameters of several different popular types and it dumps their contents in the form that it was received. On the right, you can see the result of this function, and the simplest type, that is int, appeared in the form of text. Byte A was received in 16-digit type array. Well, there's also a very special type that is similar to an array, and JSON is represented in text format, that is unpleasant, and bullet type is also represented in the form of text, so false is F and true is T. And of course that is terrible, because from the standpoint of Perl, F is just as true as any string that is not empty. What can we do about it? Well, there is a remedy, a solution. It is transform. It appeared in Postgres 9.6. This is an opportunity for every procedural language data type to write 2 functions that will transfer 2 functions from procedural language to Postgres and vice versa. And it is quite fast. In a year after transform appeared, an implementation for JSONB was available for us. So these are the functions: JSONB to Perl to JSONB. They were packed in transform, and all of that was packed in extension JSONB Perl. And after that, it was quite all right. We didn't have to parse it manually. It became Perl structure at once. But there is also Boolean type, and I decided to write contract for it. It turned out to be quite simple. These functions look as follows. It's quite simple. We receive a parameter from the function, and we return it in a different form. So, on the left, we transform Postgres bool into Perl, true or false, and on the right, vice versa, we take Perl and check it, whether it's true or not, and we return the result as Postgres bool. So that is a very simple, and this is the simplest frame. And how can we write transforms? Actually, it's very simple. JSON and transform are huge. And for such simple types, transform is also very simple. So why am I speaking about that? I want you to write transform as well. This is the result. This is a new extension that's present in Postgres 13 already. So in the definition of function, we see transform expression. We specify the types for which it can be applied, and on these paradata we can get JSON in the form of data structure, not text, and bool is received there. So false is an empty string, and this is false from the standpoint of Perl, and true is 1. This is true from the standpoint of Perl. So this task was solved, and it's very convenient, but there are other types as well, and if you want, or if you can work with extension programming, if you want to write something on C, you can write this simple solution, and probably it will be included in Postgres. But a typical task is new types or more advanced functionality of present types, such as date and time, that can be converted into convenient types that would be convenient for procedural languages, time intervals, ranges, attributary precision, numbers, and many other things. Spacious types, probably. And for JSON-B, it will be really good if someone develops a lazy transform that will not deploy the whole structure from one view to another, but only the parts that are in demand. So, welcome. Thanks a lot. I managed to present within 5 minutes.
Итак, спасибо за внимание. Следующий докладчик Михаил Жирин.
Our next presenter is Mikhail Zhirin.
Скана по здоровенным таблицам.
Так, спасибо. Добрый день.
Thank you. Hello.
Михаил, секундомер пошел.
So can I start, Mikhail? Time is on. My name is Mikhail Zhirin. I'm employed by Postgres Pro company, and today I would like to speak about a problem related to index on the scans and the way we optimized it on big tables. So, what is index on the scan? This is a good functionality that allows some queries to be executed much faster, because the data are taken not from the tables but from the indices. This is a very good definition, and you can find it in Postgres wiki. And the main thing why we need to use this index on the scans is to decrease the load on I/O, especially if you are restricted and your disk system is overwhelmed. And what are the difficulties here? Let's look at a simple case. There is a table of logs, and it contains a message and a column with a data. And we want to see logs, for example, for 2 days, for February 1 and 2. And in the sorted order, and only 100, because we do not want to overwhelm our sampling. So we developed an index for it, for logs table, with these 2 columns. And here we can look at a test table with 1 million strings. We can see that this plan is great. We use index on the scan, and we read only 5 buffers. That is great. We selected 100 strings and had only 5 reads, and all of them were in cache. So everything is fine. We go to production or to a test environment, and we can see that it's not 1 million strings, but 20 million strings. 20 million rows, and shared heap is a bit bigger, actually 20 times bigger. It was quite unexpected. Why? Because of course, we have enlarged the table, but the number of buffers was not to be increased because of that. What is the problem about? The problem is the way this functionality works. It iterates over the rows that it selected from the index and checks whether the row is available for reading or it's not visible. Probably this is a new tuple or a tuple that had already been deleted, and for that purpose we use visibility map. And the functionality of only scan index caches only a single PM page. I'd like to remind you that the visibility map page covers 256 megabytes of a normal page. And if the size of this table is more than 256 megabytes, then we start jumping between these tables, between these pages, when we iterate over rows. So at first we enter one page, and after that we can enter the other page. No one knows in what page we will find ourselves. And this procedure of heap, of jumping, is not free. At first we need to free the previous buffer, we need to find a new buffer that is associated with another page, and after that we should pin the new buffer. And we can see that these unpin and pin operations are actually exclusive, so we cannot do to these operations with one and the same buffer at the same time. What does it mean? It means that if we add load, I mean, if we take the machine that is more powerful for processors, 8 cores, if we have huge shared buffers to avoid disk I/O, then it's possible to build this chart. This is dependent on the number of rows that were selected on the number of parallel processes. In 2 tables, one table is small, 256 megabytes, and the second one is large, 2 gigabytes. And unexpectedly, we see that when a table has only one page of visibility map, the performance grows. But if there are 2 gigabytes, it doesn't happen. The reason is that here there are locks on hot buffers. Thus, our Postgres became, well, probably not single thread, but there are very few threads here. There is no growth after 16. And it requires optimization that's cached not one page, but a bunch of VM pages. And here we can see on the yellow chart that our performance has grown dramatically in the table with more visibility maps. And we also increase the number of partitions of shared buffer to get a good result. So, what is the conclusion? First of all, index-only scan performance can degrade when table size becomes more than 256 megabytes. But there is a patch that improves scalability by several times, and latency is improved as well. For large scannings, it improves up to 2 times. And very soon, this patch will be sent to hackers by our developers. Thanks a lot. Thank you. Thank you, Mikhail. Indeed, this is a cool topic. So our next presenter is Oleg Boltunov. This is the continuation of the beginning of our conference. Over the time of the conference, we received new results regarding PGConf. Now it works for Byte-in as well. Oleg, the floor is yours. Hello. I would like to renew this tradition of sprints in Postgres conferences. Actually, we had only one of them in 2006 in Toronto. We gathered and we were hatching Postgres. So this is a real photo. There are a lot of famous people here, but Fedor and I are not here. Because actually he was sitting next to me, and I could not take a picture of myself. After our presentation, while smoking, a guy came up to me. His name is Alexander. I don't remember his family name, and he said that there is a major problem when it is very expensive to stream bytes. Well, actually, it inspired us to resolve this problem. Besides, it turned out that it's actually related to our work on JSONB, and we managed to build this example. It motivated us. Look here, a table with 100 megabyte record. This is uncompressed. Just letter A. And we add 1 byte. And it takes more than 1 second. So this example motivated us. Besides, the table size increased. It was 200 megabytes instead of 100, and 100 megabytes went to wall. So this is a very bad streaming by T. What did we decide to do? At first, we decided that it was necessary to correct toast, because the current toast is not sufficient for partial updates. The matter is that all data is de-toasted before in-memory modification. So, we added 1.5 kilobytes and saw that here there were 4 new toast chunks. And of course, it is not very efficient, and we would like to have it differently. For example, if we added 1.5 kilobytes, then the things we can find inline This is the things that we can find in inline data. In that case, we have chunks that are shared, but no new chunks, but here there is a reference. And in inline, I mean in heap itself, in the recording itself, we only save this tail. And if the size is more than 2 kilobytes, then we can save first chunks. So these 2 first chunks are saved, and the third one is modified. So we have more chunks here. Thus, instead of 4 new chunks, we have 2 of them. Let's repeat this example. We can see that as a result, we had 2,750 times speed up. So it's about thousands of times. And in this example, we can even predict maximum benefit. If the length is 1 gigabyte, then the benefit will be 27,500 times. The size of the table is similar, 100 megabytes, and only 143 bytes were sent to wall. So there were no unnecessary buffers, neither read nor written. This is a good example. And we developed a more detailed example. Here we took a table with 100 recordings of various length, and we made append from 10 bytes to 1 megabyte. On the left, you can see master. The time of query is proportional to the length of the previous and the new recording. This is toast. So actually it started, and after that we can see growth. This flat errors, well, this is because 10 kilobytes are added here. It is more than 1 kilobyte. That's why only its size is determined here. And with our patch, we can see that time depends on the size of the piece we add only, but it does not depend on the length of tuple. So here the maximum length is 1 megabyte. So the benefit is 1,000 times in terms of time. Let's look at wall traffic. Here the picture is similar. Master is really bad. And this is the reason of the things that Alexander saw in his examples. And here, due to our patch, we can see that for large additions, the size of traffic depends only on the size of this addition. That is quite natural. We added it and we should log it. And this is an artifact. This is the growth of wall until it reached the size of 2 kilobyte tuple. And actually this is our fault. Here we log from the old inline tuple. We should not log it, and in that case everything will be fine. The matter is that we were doing it overnight. So we realized that everything is possible. We demonstrated a very good improvement, 1,000 times improvement. And you can play with this branch. Here are the slides. So this was a very fast hack, an experiment. It's not Postgres 14, but it opened a space for us to unite our efforts in terms of JSON-B improvement. And here there are a lot of things. I'm not sure that we need to optimize insert delete, but speaking about prepend or truncate, I think it's possible to optimize that. We need to add compression. We need to generalize data form for partial updates of plain data types. And the main thing is that our toast should be pluggable, so the data type should know how to be toasted in a better manner. Once again, this is our contact data, and if you want to work with our team, you can write us. And this example has shown that your cases are really important for us. So 5-minute talk with this guy made it possible. It motivated us to make a new development that opened new tasks for us. So please write us about our problems when working with Toast. It will allow us to improve new AP for working with Toast. That's it. Thank you. Bye.
Так, Олег, спасибо большое за доклад.
Oleg, thank you for your presentation. Our next presenter is Vladimir Sitnikov. So, he will speak about committing. Yes. So, fixing or falling back. This is a good topic for the end of the conference. Let's speak about fixing transactions. Well, my name is Vladimir Sitnikov. I work in a technical company, and I am a committer in PGConf.Online. This is a Java driver for Postgres. So, commit. How should commit command fall? Well, actually, commit command doesn't fall. Postgres is a reliable database, and the conference has proven it. If there is an error, we can dump the error, or we can have errors, but commit should actually commit this transaction to make the database integral. And probably the smartest people can say that we need to think about it. Probably it depends on the situation. So can you select the correct answer here? This is the simplest option. We create transaction, try to eliminate the sequence. It is not eliminated. We launch the next query. And I think that each of you has seen that one error happens, and after that, nothing is possible. The base says there is an error in your transaction, and every query will fall. How can we finish it? Of course, we need to commit this transaction with state commit, and that's it. So we committed this transaction unsuccessfully. Probably there was a rollback. This is a basic example. There is nothing new here. Well, I can already hear some people speaking about deferred constraints. Indeed, if we create a table where there is deferred constraint, for example, it was deferred manually or by default, and we insert double strings, and what will happen? Of course, it will fall when we try to commit the transaction. And how will it fall? It will state that this string is not unique, and you cannot do it because Postgres is an integral base. So it means that commit can fall. That is something new. Let's think of not 2020, of which you thought. So there is an interesting observation. 1 year ago, a letter was received in PGSQL hackers mailing list. So it states that there is a standard that describes what should happen when commit falls. Well, we've just seen that an error, it falls, and what are the problems? But this author was quite smart, and he considered a different option, but commit is not committed. Everything starts as usual. We launch a transaction, and after that, we take a wrong SQL expression. What will the base do? Well, we say commit, and the base says, well, the transaction is incorrect. Here is rollback. So, what is rollback? We actually required for commit, and the base says rollback. There is no criminality, no errors here. And, of course, if there is an error, it is better to dump it. But it depends on the situation. So everyone starts to panic. What should be done here? We cannot roll back. And what does PGDBC do? The driver repeats the behavior of the base, and it does not try to develop a different base out of Postgres. That's why we do it in a similar manner, but our users do not expect it. So we said we know about this error, and let's develop a patch that will understand what these fallbacks are. That will state this is an error, so we committed it. The users came to us once again. And it turned out that applications were not ready to the fact that such errors are already present. So what can I recommend you? First of all, check whether an accidental transaction rollback appeared. Just imagine that you are committing transaction, the data are rolled back and you do not know about it. Well, probably someone can offer to write a patch in Postgres. That's okay, we can write a patch, and it turned out that commit operation has an interesting continuation, that is commit and chain. So if you knew it, well done. I didn't know about it, but it turned out that this is a specific amount, commit and chain. It commits and creates a new transaction right after the end. Well, will it be successful or not? And what will this arrow mean? So this is the beginning of the next one, or this is a different arrow. So we have a connection problem. Vladimir is not with us. But actually, his presentation was quite interesting. Probably he will manage to return, and we will listen till the end of his presentation. But now I would like to mention that the conference is being ended, but we decided to give free mic to our audience. So if you would like to say a few words, you can write about it on the chat, in the conference chat, and after that we will try to show you on air. Probably someone else wants to say something. And now, I would like to thank our participants. I would like to thank our participants. And of course, I would like to thank our speakers, because a conference is not possible without speakers. And I also want to thank the organizers. Well, we are the organizers, actually. Just a moment. I guess that Vladimir is... No, Vladimir is not connected. So I would like to thank everyone who participated in this conference. I would like to thank everyone who asked questions. And it's really great that apart from questions, we also had discussions in special chat. I actually liked it a lot. I think that we can continue using it. I would like to thank the people that were ranking our presentations. Actually, we have our ranks, and I will disclose them in a few minutes. I would like to thank our partners that rendered financial assistance. First of all, we have our golden partners, Intel and Nutanix, and it turned out that Intel is famous not only for its processors that everyone has, but also memory devices that are very good for databases. And actually, we had this presentation, we'll have a chance to see it later, and Nutanix develops and produces cloud platforms for industrial usage. And I'd like to mention that this is a partner of Postgres Pro company. We help make Postgres better for this cloud platform, and this cloud platform is also quite good. And we also would like to thank all the partners, and probably we will say a few words about them in our mailing. I would like to thank our technical team. I think that we've had one of the best technical teams in this country. These are the people that organize High Load Conference. And of course, we will continue working together on Postgres conferences with Avantika team, because they've done a great job. They've undertaken a lot of work, and although we have had some technical problems, but still, everything was quite successful. I would like to thank our interpreters. Actually, I managed to listen interpretation, and I can see that they did their best. And I understand that this is a very difficult job. So, for several years, they have helped us. Well done. Thank you, interpreters. And actually, we have received some words of gratitude from our foreign colleagues for the interpretation into English. That is great. What else do I want to mention? Some numbers. More than 221 participants registered on the conference. This is the largest Postgres conference in Russia. I don't know whether it's the largest one in the world or not. We had 172 guests who were not from Russian, and they were listening to English interpretation. 20% of all participants registered during the conference. So this is an advantage of an online conference. You can come any moment and listen to what you need. And among all the participants who registered, 75% attended the conference, but these data were actually calculated in the middle of the day. Probably this percentage will be higher now. Speaking about online events, well, actually, it is considered that if half of the people that registered for a free offline event came, that is great, and 75% is very good indeed. We had 57 talks and 59 speakers. Well, it happens in the world of databases. And who are the champions? Here there are two classes. Well, by tradition, we do not give prizes, but we mention presenters from Postgres Professional company because actually it's not appropriate to give prizes to ourselves. Two more popular presentations were presentations of Nikolai Samokhvalov, Seamless Query Optimization, and Andrei Zubkov, PG Profile and PG Pro Power. So they received a lot of feedback, very high-level feedback, and although we did not have many presentations for one scene, probably we did not have a lot of audience for one scene, but actually Anton Vershkevich had two presentations, and his presentations were highly ranked, but the presentation about compression was ranked the highest, and actually Anton is the only participant that for each of his two presentations could get into the list of champions. And quite recently, because this presentation actually was given recently, and it has reached quite high values. This is Daniel Westerman with data migration. Ivan Falkov's presentation got up in the ranking also quite fast. He was speaking about constraints, and also Oleg and Nikita with their presentation about JSON-B are in the top as well. So actually our winners are very close to each other. We've had a lot of high marks, and the average rank out of 5 is 4.8. So it was quite difficult for us to select our champions. But we selected a mathematical algorithm. So the champions will get a prize. Thanks a lot. What will we have after the conference? Well, first of all, there will be a link for questionnaire. This link should appear in the chat, and after that, we will also send it in our mailing. We want each of you to fill in the questionnaires to answer the questions. So this is needed for us to improve the conference. This is our first experience of a big online conference. Of course, we will learn something in the process, and we will learn other things on the basis of your feedback. Everything will be published. The speakers do not mind, and by tradition, still there are 1 or 2 speakers that do not want to have their presentations published. Sometimes this is a restriction of an employer, and sometimes people do not want to have their presentations published because they are worried about their appearance, for example. But we will try to publish everything. Of course, it requires some time for technical stuff. And please monitor our news. There will be next events. A lot of interesting things are happening in the world. There will be an offline high vote in the end of May, and of course we'll participate there. Probably we'll have an offline event, PGConf.Russia, in June, but I guess it will not be as large as this one because we've just had an online event. But I think that many people, including our speakers, want it to have offline, and they're saving their presentations for offline events. So monitor our news. We will decide it soon. In Russia, we are having a new platform for conferences. It is in Sochi, and there is a probability that we will conduct a conference there in September. Israel is also going to conduct a conference in September. well, if they open the borders. And if yes, then probably they will open this conference as well. And also, I hope that we will have a conference in Siberia in November. And I hope that we will manage to conduct a conference in Europe this year. And actually, we liked online format. And in 2021, we will also conduct a major PGConf.Online conference. I hope that it will become even more international and even larger. So the question is, what format should be selected for an online conference? Should this format be similar to the one of normal conference? Well, according to your feedback and our experience, we will try to devise something better. And I hope that next year PGConf.Russia will also be conducted. And there are other conferences conducted by Postgres community all over the world. Thanks a lot. So I'm saying not goodbye, but commit.